so much for being here on time and ready to go. I'm very nervous, I will freely admit, but I'm also really excited for the program that we've been working on and have put together, because I feel that hopefully we're bringing you a range of experience and information that you can take back with you to your communities, your teaching environments, and your offices, your work, wherever it is that you are working. So should we just test it out?
Hello, yes. Hello, good morning, folks.
Good morning. Okay, so I would like to take a moment to welcome Luciano Romano. I hope that I said that reasonably correctly. He is a technical principal at ThoughtWorks. He's a community leader, and he shares his knowledge through numerous things, including giving speeches and talks throughout the world, and also through his writings, including his book, Fluent Python, which helps us not to only understand what to do, but why we are even doing it in the first place, which I think is a big challenge for me as a self-taught learner. I see the what a lot, but I'm always struggling to kind of find the why, and that's a big part of the research I do as a self-taught person. So I'm really excited to hear what Luciano has to share with us, and without further ado,
Thank you very much.
Romano.
Thank you very much, Jess, and the organizers of the summit. I'm really happy to be here. Actually, I submitted a talk, but the organizers found it was a good idea to invite me to give a keynote, and not about the topic of the talk, but about my wider experience teaching and so on. So this is the kind of talk that really excites me. I'm really nervous, but it's like I remember when in school when you had a free theme composition, right? You can write about anything. And for me, I love the opportunity, but also I was always very stressed out, because then you want to write the history of the world or whatever, and there's never enough time. Anyway, so what I decided to do, as I exchanged emails with Jess about what I could talk about, I had several ideas, and she said, wow, these ideas are great. So I decided to talk about lots of them. All right? So that's why this talk is named N Lightning Talks, because it's really going to be several talks about different topics, one after the other. But I want to start with a slide, this picture that was shown to me by a person that I'm going to talk about soon. Who knows what this picture depicts? Yes, the first transistor. And the guy who showed me this picture in a classroom, his idea was to explain that every technology, when it starts, it's sort of handicrafted, right? This structure here was about 10 centimeters high, so it was a human size. You could actually, use pliers to adjust this wire here to change the distance, for instance, to change the pressure or whatever, while they were testing the idea of the transistor, right? But at the same time that it is something that is very, on this human scale, it's like almost a craft thing. It also contains decades of particle physics inside, in terms of knowledge, right? And I always found this very inspiring, and this is a closer picture. But anyway, so I'm going to start doing a live demo of something that I like to use to introduce programming to people that sort of has the spirit of that picture of the transistor. So I'm just going to open the terminal and move it there so that you can actually see it. Oops, terminal. All right, so let's make it big. So how does this go? I just launch Python 3, and then I say, what I'm going to do is, I'm going to build a functioning clock in 5 minutes without using an editor, okay? So, the clock is, let's call it CK. Okay. This appeared. This window wasn't here before. This was the result of creating this label instance. Okay. So let's put some text in it. So you see the number there, but it's too small, so let's put a nice big font. All right. Okay, so let me just arrange these windows here so that we can see it. Okay. Oops. All right. So how do I update the clock? I do from time import strf time. And for instance, so strf time is a funny function that you pass it this funny string with the parts of the date time that you want to display and how to format it. And it gives you a string with the time. All right? So let's do a function to update the clock. I'm going to call it tick, because in Portuguese we say that clocks go tick-tack, and we spell it very simply with TIC. So tick is one function that does basically this. All right, so now when I call tick, I have the clock updating. And I can do this here like a human program. But I can also do another function called tac. And this, what does it do? It calls tick, and then it says ck.after, after 1,000 milliseconds, call tac again. And then I go tac, whoops, sorry, tac, and now the clock is running, right? And one thing that I find really neat about this is that you can still interact with the clock. I can, for instance, change the foreground color to red. If I read the text property, I'm actually inspecting the value that is displayed right now every time I do this. So it's you interact live with the running program. So anyway, this is one demo that I like to do, and I like to do it for several reasons. First of all, I think it's important that people realize how powerful the interactive console is. And I'm going to talk a little bit, I'm going to go back to my slides because, yeah, so what happens is I learned to program in the 80s. And for me, it was a very happy experience. I really enjoyed learning to program at that time. And I keep trying to create or to bring back some of the interest or some of the good things that there was about learning to program in the 80s today. What I learned to program was basically a calculator, because at the time in Brazil, actually it was the late 70s, there were no microcomputers for sale in Brazil, but there were programmable calculators, and my father got one in his company. They gave him one. He didn't care to use it, so he gave it to me. And I started to program it. Actually, my first program was a conversion of a program from the HP25 to that other calculator. And the program was the moon landing program that's famous, right? So I saw a demonstration. My uncle, who is an architect, had an HP25, and he went to visit us, and he showed this lunar landing program. Now, you have to realize that the display only shows numbers, all right? No letters at all, not even A, B, C, D, E, F for hex numbers, just digits and a decimal point. And so you basically played by, whenever you hit enter, it would update the display showing the height of the ship and the speed after the decimal point. And then when you wanted to decelerate, the idea was that you would stop this fall by decelerating. And you decelerated by burning fuel. And you burn fuel by typing a number and then hitting enter, and that would affect the computation of the next iteration of the free fall. And it was fun because if you burn too much fuel too soon, what happened was you slowed down a lot. You could even go up. But then you ran out of fuel and you were really high, so then you would crash. So the challenge was really to play a few times and understand when to do the actual burn of the fuel. If you took too long, then you'd be going too fast, and it would be too late to decelerate. So anyway, I was fascinated by this. I already was very much into board games at the time, and I thought that this opened a huge opportunity of board games where some board games have some complex bureaucratic stuff that you have to take care of. Some board games even have tables, you know. And so those kinds of board games, I thought they could be automated with a calculator, and that was what really fascinated me. And so my first program was I borrowed from a friend the manual for this calculator. I must confess that I never returned it until today. And then I learned the notation of the HP calculator to program it, and then to port the program to the TI 58, which was the machine that I had. So that was my first program. And programming looked like this, okay? Because since you only have a single line in the display and it doesn't show any characters, you better write down on a piece of paper. And you see there is an edit here, right? I had to add this instruction that I forgot. So anyway, this was interesting. And one thing that is fun is, okay, maybe Luciano, you're too weird. That's why you enjoy doing things like that. But the thing is, I have a younger brother who now works with computer graphics, and he is about 6 years younger than me. And so after I had moved on from the calculator and was programming microcomputers and so on, this brother of mine got into that. And I couldn't understand. I said, why are you doing that? Now we have a microcomputer at home. You can program in BASIC. But he was interested in this. So my theory is that he was interested in this because it evoked this, you know? It was like you had this feeling of what is the bare essential of programming. That's the bare essentials, right? Anyway, then I went to, then I came, I was very, I'm a very privileged person. I come from a high middle class family in Brazil, and I was fortunate enough to do an exchange, to be an exchange student in the US. So in '81, when I was 16, 17, I came to the US and spent a year in Harrisburg, Illinois, which is a very small town. Still, it's actually a bit smaller now than it was before. It was about 10,000 at the time, and I visited them about 3 years ago, and it was 9,000, something like that. Because it was an area where the most important economic activity at the time was coal mining, and that was in decline. But something happened there that really mystified me, and this, I'm going to tell you this idea because I think we should. I would love to talk to you about why this happens and how to fix this. So the thing is, so I knew about microcomputers because I read magazines in Brazil that talked about microcomputers, but I didn't have one. So I came to the US, and I was a junior because there was this split, in Brazil with the year. The school year starts with the year, not in the middle of the year. So for the first half of the year, I was a junior. And so there was study hall. Is this still a thing, study hall? I thought that was the most insane thing I had ever seen. I couldn't just stand it. For me, it was torture. To be in a room with a teacher whose only job was to keep everybody quiet. And you could do anything as long as you were quiet. Some of my colleagues did homework. Some of them read magazines. I slept most of the time. But anyway, but it was torture. You have to be. I kind of, out of just a revolt, I wouldn't do homework when I was there. I left homework for home. Because when I was there, I was just thinking, what am I doing here? And then, like a couple weeks into this experience, it was really painful for me. What happened was the librarian came into the study hall and said, kids, I don't know if you know, but the school just got 5 computers, 5 Apple II computers. One of them is going to be used in the administration to check attendance. And the other 4 are going to the library. And however, we don't know how to use them. Nobody in the school knows how to use them. There's a teacher that's going to take a summer course to learn how to program, and then he's going to teach you courses in the next semester. But right now, we have 4 computers in the library with no use. And if you want, you just raise your hand, and you can go there during study hall. And there was 60 people in this study hall. And only I and one other person raised their hands. So I think this is really shocking. It's something that it's a memory that I keep with me, because what is it that we do in our schools that we kill people's curiosity at that level, where 58 people thought it was more interesting to be in this room where you couldn't talk than to go, play with this computer, whatever, So, and the computer had a manual, all right? And the manual taught you how to program. This is a big difference between a modern computer and the computers at the time, right? The computer came with a manual that taught you how to program. And when you turned it on, what you had was a prompt. So what do? Program, right? And anyway, so what do you think? Let's start this conversation. Why do you think this happens? Were they afraid? What's the explanation? What do you think? As people who have endured years of study hall, maybe you have some insights. Come on, folks. Yeah. Sorry? Fear of failure. Yeah, that's a good point. Yeah. Interesting. Although there was no pressure, right? Nobody would be watching. Nobody was watching. The librarian was really nice. you know. So, but I agree. I think this is a factor. Peer pressure. Yeah. Yeah. Uh-huh. Interesting. Yes, Carol. Yeah. Yes. Yeah. Totally. Yeah. The librarian couldn't sell this stuff. She was just saying, "This is a fact. We have this." She was very nice, and very welcoming, and she loved us. Me and Bill, the other guy who went, you know, because then we became like her pet students because we were the guys who learned to program by ourselves on the machines and so on. Yes. No, that was really early into my experience, into my year in the U.S. I didn't really have friends, 2 weeks into. I made friends later, but at the time I didn't have friends to ask. But this is, yeah, I should have asked. Maybe actually it took me a few years to realize how weird this was. I don't know. Anyway, I brought with me to Brazil a computer that I could afford. I could not afford the Apple II, but I could afford the TRS color computer. And one thing that I found really interesting when I was reading the preface of the first book about the Raspberry Pi, I forgot the name of the book. But anyway, the preface of that book is written by Eben Upton, who is the guy who initiated the project, the Raspberry Pi project. And one thing that he says is really interesting is that the reason why he got interested was because he's a computer science professor, and they realized, I forgot, I think it's Oxford, I don't know, Cambridge, yeah, okay. So anyway, he's the computer science professor in Cambridge, and they realized that over the last 20 years, there was a decline in the number of people that joined the program as undergrads that knew how to program. And this is something that I observed throughout my career. Because at my age, when I was like 17, 16, 18, it was easier to get started as a self-taught programmer, right? And there was more encouragement, even in the form of the manual that came with the computer and so on. And one of the things he says is that, okay, in England, supposedly, or in Britain, supposedly almost every house has at least one computer. But the difference is the Raspberry Pi is a computer that's built for hacking. And this was important because when I had my first microcomputer, the microcomputer wasn't useful to anyone except somebody that wanted to learn to program. There were no, social networks or Google or whatever to use the computer for other stuff. And so this is a key advantage of the Raspberry Pi, is that because it's limited and it's small and it's slow, it only will interest somebody in the household who is interested in programming, in learning to program. And anyway, okay, so let's talk about something else. My first job my first real job was teaching programming in Brazil. At the time, there was a Brazilian clone of the ZX80 machine from Britain. In Brazil, there was this law that basically, it was a weird thing. We had at the time, there was a military dictatorship in Brazil, and they thought that computers were strategic, and they decided to build a Brazilian computer industry. So how did they do that? One of the things that they did was they forbade the import of computers, although of course IBM was already there and they had exceptions for them. But for microcomputers, you basically couldn't import microcomputers. And then there was a homegrown industry of microcomputers that were basically clones, and the government did not recognize intellectual property from abroad. So basically, some Brazilian capitalists got a free letter from the government, just pirate the stuff and build it here. And that was done. Anyway, so my first job was teaching people to program this ZX80 clone, and then I was hired. I was working at this place that teaches vocational courses, courses for professional courses, and then I was transferred to another unit that did software development. We developed software for the Apple II that was used for teaching stuff in other areas of the training company. Anyway, and at that time I discovered Carol the robot. This is an old book. There's several new editions of it, but the main idea is that there is this environment that is more limited than the turtle environment. And I think it's very interesting because it forces a kind of a discrete thinking and programming that is more easily transferable, I think, to other kinds of programming. So the idea is, for instance, you have this arrow here represents Carol the robot, and the robot only turns 90 degrees and moves along those lines. So, for instance, this is a situation where you have to program it to eat these 3 balls, right? So this is the start, and this is the end. And I didn't have access to, there was no internet at the time. So I got the book on a bookshop, but I couldn't get the program that ran it. So I re-implemented some of it in Lowball. And we used this to teach introductory programming. But after some time, I discovered that there was some things that happened right in the beginning with the contact with Carol that were really interesting and that were worthwhile focusing on that. And so I invented this other thing that I called Lowball, and that I am planning to redo. And now it's going to be called Steps. But I didn't have time to redo it, so I just did this drawing for you guys to understand what the idea is. So the idea is you draw on the screen this path, and you have this robot here that you control. And basically, you teach them, you have one command. The command is the letter F. You press F, and it goes forward, okay? And your goal is to get to the star, right? Of course, there is another command, which is left. So left, it turns 90 degrees to the left. Oh, but I need to turn right. Okay, so turn left 3 times, and you're good to go, okay? So the idea was, after teaching them these commands, and I implemented this in the Apple II at the time. People could play, so a random path would be shown, and people would play and get the hang of the F and the L. All right, okay? So after some experimentation with this, I would tell them to turn off the computers, and now start writing the commands on a piece of paper. So I would show a path, and they would write the commands. And I think this was really useful to bring them into this state of mind that we need to achieve to start programming, which is to start thinking as the computer, right? So this was the next step, to start writing down programs. And I actually passed out handouts that had the paths, and people would code, and then people would correct each other's exercises. And we did some exercises of this kind of coding. And then I introduced another idea, which was the T key. And the T key was for testing. And what did it do? When you hit the T key, it would emit one of 3 sounds. One sound, like a would be when there is no path ahead. Another sound, a nice sound, would be when there was a path ahead, and there was a different sound for a path that you had already covered. Okay? And now, after you teach them this, and they keep playing with the noises and so on, oh yeah, and if you hit forward anytime, and arrow was pointing not to a path, it would fall off, and there was a crash sound, and you would have to start again, okay? So now the interesting thing is that once you introduce the T, you can program this thing, or at least command it interactively, without the screen. You could turn off the monitor, and then you would just, by listening to the sounds, command the robot. And I think that helped even more for people to put themselves into the shoes of the little robot. And because the T and the lack of, the blank screen and the T meant that you could only look at one thing, right? And this is what key characteristics of the computer. The computer doesn't have a holistic view of anything, right? You can program it to recognize your face, but it's going to be looking at pixels, right? So anyway, okay. Now let's talk about somebody who really influenced me, and this was Etienne Delacroix. He's a physicist, an artist, and a teacher. There's a chapter about him in this book, which is written by a guy who was at the Media Lab, Neil Gershenfeld, who was director of the Center for Bits and Atoms. Isn't that a great name? Anyway, he wrote this book called, it was kind of one of the Bibles of the early stages of the maker movement, this book. And there's a chapter called Etienne, okay? And in this chapter, he talked about the work that Etienne was doing at MIT at the time, and then that he went on to do in Brazil for a time. And what was his work? Anyway, when I met him, I was studying at the university. I was a late student because I went to work before I graduated, and I worked without a degree for like 20 years, and then I went back to the university. So I was lucky enough to be in the university when he was there, and he was teaching this class called the Art and Programming Workshop. And what was it? The idea was to show people, to encourage people to use electronics as a means of artistic expression, right? And when he did a lot of stuff with junk electronics, computers that were thrown out by the university, things like that. And he encouraged us to, each of us in his class had to assemble our own computer out of parts. And we would use steel rods like that to build a structure and leave everything open so that you could attach stuff to it. Anyway, so more than anybody that I've seen teaching, Etienne taught me how to focus on what's really essential. For instance, his entire talk about HTML, and this, I need to explain. This class was open to anybody in the university, okay? There was people from the art department, from the library sciences department, from the engineering, from physics, whatever. And his explanation about HTML was like this. He showed a simple HTML and said, notice this has a syntax. It's like Russian dolls, things inside other things, inside other things, and so on. Okay, he had a picture of Russian dolls. All right. There are many tags, but you can learn about the tags elsewhere. For us, what's really important are two tags. The div tag, why is it? Because it's like, how do you call the kind of jello that has no taste or color? How do you call that? That used in cooking? Gelatin. Yeah, so it's like gelatin. Div is like gelatin. It's something that doesn't have any visual effects, but you can make it look however you like, right? So, and then there's the script element. And then he would say, now you have another language. And you can write little snippets of JavaScript to control the div. And that's all that matters. So I thought that was a really exciting way of introducing HTML. And then he encouraged us to play with it. And I already knew HTML at the time, but I noticed that it worked with people that were in the workshop, too, this approach. And he was always talking about the importance of the silliness of the question, which programming language to teach first? Because he thought it was much better to teach at least two at the same time. Because that allowed people to realize what were the principles that exist across languages. Right? He forced me to use TCL/TK, which I hated initially, but then I came to love. And he did it on purpose because I think he wanted me to, try this thing that you don't know about. He wanted me out of the comfort zone or whatever, the safe zone. Okay, so from his ideas, I wrote some stuff to teach programming. And one thing that one of the reasons why I felt sort of an imposter syndrome when I was invited here is because, unlike you, I'm not a practitioner of teaching programming to people right now in my life. I probably will go back to that. I did that a lot for a while. But nowadays, when I teach programmers, I'm usually teaching some new language or some advanced feature of a language or some API or something that's, I'm not teaching, I don't have much opportunity of teaching beginners. But I did write some things like this Learn to Program tutorial, which I wrote many years ago, and that often people come to me and say, you know what, I learned to program using your tutorial. And one of the examples that, so I'm really into the issue of examples, and this is one of the things that I love about Alan Downer's work, because for instance, in Think Python, the examples are awesome and varied. One problem that I find in many beginning computer books, programming books, is an overemphasis on numeric examples. But Alan knows better than that. For instance, he has a whole chapter called wordplay and lots of interesting examples with words, and that encouraged me to seek some more stuff about that. But anyway, for instance, one of the examples that I have in this book, which is it's a numeric example, but it's really simple addition and division, is a program that calculates the budget for a picnic. Right? So this is something that's actually useful, and it's really simple. So the program asks the name of a person, and then asks how much that person spent in the picnic, and the other person, and how much, and so on, and until you enter the blank name, and then it would spill out a report that is just simple arithmetic, but it's useful. That shows, okay, the total spent was so much, the average per person, each person should pay so much, and then depending on how much people paid, it would say, so this person has to get so many dollars, this person has to pay so many dollars, and so on. Okay, so it's a short program and it's useful, and it's the kind of examples that I think we should try and do more. Another thing that I find interesting is a trick for doing interesting examples is if you rely on data, or if you rely on data. So for instance, Python has an awesome calendar module, and that has a lot of data, right? It generates data for you, calendar months, calendar years, and so on. So if you do exercises using that, with a few lines of code, people are seeing results that are interesting. Another example of something that I did, for instance, in my book, Fluent Python, there's a few chapters about concurrent programming. And the classic example of a network program that is concurrent is Echo. Come on. Echo is really silly, right? Can we do better than that? Yes. So one of the things is Python has the Unicode database embedded, right? So what I did instead of just an Echo program was a program where you typed a word and it would respond with Unicode characters that have that word in the description. So if you wrote chess, you would see chess pieces. If you wrote chess black, you would see the black chess pieces. If you wrote cat, heart, you would see little emojis of cats with hearts in their eyes or something, right? So this leverages the fact that there is data embedded, and you can use that to provide the interesting results. Doesn't need to be embedded. For instance, in Alan's book, he uses a dictionary. So one of the challenges when we translated that into Portuguese was to find a good Portuguese language dictionary to do the plays with words there. Anyway, so another thing that I did as I was influenced by Etienne Delacroix, was that I was invited to present a workshop that was called sort of like Programming for Fun. And this is at a place called SESC. Now, there's nothing like SESC in the US. Even the way that it's funded is weird because it has to do with the commerce and services sector. There's a tax, and they basically fund these cultural centers. There are places where there are theaters, there are shows, and there are lots of courses going on. You know, teaching photography, teaching Tai Chi Chuan, teaching, I don't know, sculpture, whatever. And so out of a menu that includes things like sculpture, photography, swimming, and there would be an option called Programming for Fun, okay? And one of the rules that SESC imposes is no course can require prerequisites. Every course must be open to all. So that was a very interesting challenge. And my idea was, it was like a 20-some hour course. It was about 8 meetings or something like that. And my idea was, okay, I can't really teach programming in 20 hours, but I think I can provide them with an experience of what it feels like programming. And one of the things that Etienne said was, before understanding logic, the algorithm thinking and so on, there's another obstacle for people nowadays, which is they've been used to computers for a long time, but they use interfaces that offer direct manipulation. So a shocking fact is when they realize that to program, you have to edit this stuff here, and you're going to see the result there that doesn't look anything like it. So there's this abstraction. And a metaphor that I used to talk about that to the students was the movie The Matrix. So The Matrix is the first blockbuster where the heroes are programmers, right? And what is the power that they have over everybody else is that they can read the source code. And the source code doesn't look anything like the simulated reality where they live in, but it gives them absolute power, or not absolute, but huge power over the simulation, right? And so this is a metaphor that I use. And so at SESC, what I did to exercise this gap between the source code and the result was to teach them to do SVG, and by hand. The thing is, if you export SVG from any program, you're going to have a mess. But you can actually sit down and write ellipsis, tag, put some numbers, and you have, with one line, an ellipsis drawn. And then I taught them that, and then we played with generating SVG with Python and so on. And I'm going to finish by talking about hackerspaces, okay? So there's this book that was very influential, Mindstorms by Seymour Papert. And in this book, there's this part here that I reproduced, but I won't read because I don't have time, where he talks about samba schools. It's a Brazilian thing, right? So there's the carnival in the big capitals with all those floats and so on. And those floats and all of the dancing and the fantasies that people wear and so on, the costumes people wear, they are built on samba schools. And samba schools are are places where people go to practice samba, to learn sewing, to do a costume, learn how to build a float, and so on and so forth. And anyway, in the book, he talks about the learning environments, but the thing is, there were no hackerspaces at the time. And the thing is, the hackerspace, the modern hackerspace, is a realization of this wonderful idea of this place different than a regular school, where people are motivated to learn by doing, from people more experienced, where there is no age difference, where young kids are learning to play the drums with a 70-year-old guy, and this is wonderful. And so we have a hackerspace in São Paulo called Garoa, and in there we invented this thing called the Arduino Coding Dojo. We have this panel that is like a big Arduino, and I'm going to finish by showing this activity that we developed there. We actually have a hardware now that's this shield that attaches to the Arduino, and the way this finishes is, the way this starts is actually, I show them the Blink program, and I do this with, it's a 45 minutes activity for guests in the hackerspace, and I've done it in schools as well, and so on. And I show them this. Most people have never programmed when they come to this activity. So this is completely cryptic. You don't understand anything. Is that right? Yes, everybody agrees. No, you do understand. I promise you. For instance, if you run this program, see this LED is blinking. Okay, where do you think we should change the program so that another LED will blink? And it's obvious because it says on the first line, int LED equals 13. And then I tell them, and where would you change to change the speed? And then there's the delay function. And just knowing the bare extensions without ever explaining why a void is and so on, we do the coding dojo dynamic, where people in pairs spend 5 minutes coding and then they change and so on. And people invariably finish by doing what the idea, which is to do an animation with the segments around the perimeter. And they do it by just doing copy and paste. Everybody is able to do that. So the only time where this failed was when it was a class of teachers. And I think the reason was fear of failure. When I explained what we were about to do, they said, no, this is impossible. We've never coded any, we can't do that. And I said, I've done this 30 times already with different kinds of people. Everybody does it. But we spent 15 minutes arguing whether it was feasible or not, and then they managed to make the activity fail. Anyway, so this is what I have time to say. I hope this was useful for you. And come talk to me about other stuff, all right? Thank you very much. Yes, I do. I will be here the whole day.
Okay. We have about 10 minutes, I think, before the refreshment break actually officially starts.
Mm-hmm.
So if you have some questions for Luciano, we can take a few minutes to do that.
Cool. Thank you. Yes.
So you have this room full of teachers frightened.
Yes.
How did you win the argument? What did you say to them?
Okay. So one of the things was, they were teachers in the public school system, okay. And then after a while, I realized, come on, I remember, wait, you guys are physics and math teachers, right? Yes. And nobody there was older than me. So I said, then for sure, you've all had at least one programming class in the university. Maybe you learned Fortran or Pascal or Java if you're younger, but I'm sure, right? Everybody did. Yes, everybody did. They agreed. And then I said, and I am sure there were about 40 people. Some of you enjoyed. Maybe not most of you, but some of you, I bet, did enjoy. Who enjoyed? And so, like 3 people raised their hand. So yeah, okay. So please come. Let's start this. This works, okay? And the frustrating part for me was that we had a very hard time slot because it was in the middle of this whole event. And it was really the only time where we didn't finish the animation. The idea is to do an animation that just lights up each of the LEDs around the perimeter of the display. And then there's a potentiometer, and the second step is to make the potentiometer change the speed of the animation. And for instance, this was also an effort in simplifying, because I wanted something that, when we started thinking about this activity, something that was more interesting than just blinking an LED. And so this was like the first MVP. So, okay, let's use a display. So we have 7 segments and a dot. So there's stuff that we can do. And then, but the thing about displaying digits is kind of boring. It's too much work. And then I had this idea, no, let's do an animation. It's simpler to do, and the effect is more fun because people don't expect to see something like that in a display. And anyway, so that was the idea. Yes?
You saw my presentation for later, but you captured what, we're probably about the same age, and you captured, like, amazingly what it's like to explore and think and problem solve and, you know, things like processing now. Like, Python's great.
Yes.
The other languages are equally fabulous.
Yes. Yeah. No, totally. Yes, that would be awesome. And I think processing is awesome, but now it's even better because there's Python mode for processing, right? And that really helps because it's in a first introduction like the Arduino Coding Dojo, it's fine to get over, just ignore the details that we're not going to talk about, okay? So people just copy and paste and it works and everybody's happy. But then oh no, okay, but what is this void thing? What is this public thing? Come on. And it's difficult to explain. So I think Python processing is a good opportunity for us. Yeah. When the first mini PCs, I call them mini PCs, they're single board computers like the Raspberry Pi and so on, started arriving. We got some people travel and bring stuff to the Garoa hackerspace in Brazil. I do that all the time too. And so we started having this collection of different devices, and we did the Coding Dojo with each of them. The same thing. Okay, so let's do the same idea with the Raspberry Pi, plug to a 7-segment display, have this 0 programming challenge, and do this, and so on. And after we did it with about 3 boards, I realized that something was really stupid. We could do all of them, we could code all of them with Python, but the APIs were completely different for doing the exact same thing. So then we started a project in Garoa called Pingo, which is a uniform API for different devices. So it uses whatever is the native API of the device that usually is already written for Python. So we just put this facade API on top of it that makes it uniform. But the project is a little bit dead now, to be honest. But we did do enough to be able to do something like that with 8 different boards and things like that. And also, it's very fun to program even the Arduino, because you can do the Arduino, you can remote control the Arduino with the Firmata protocol. And so it's fun to do a demo where you open a prompt, just like I did the clock, and you're actually issuing commands to the Arduino and making stuff happen interactively. And this is something that you can't do with C. Right?
So
Yes?
you talked about transistor
Mm-hmm.
So to start getting young minds curious about electronics and
Mm-hmm.
program them, what do you recommend? Should we go back to the basics or start with the ready-made kits that we get today?
Well, I have limited experience. I taught courses to like 10 or 12-year-old kids just twice in the last few years. And well, first of all, and we were using Arduinos at the time. And I think Arduinos are great to encourage people to learn to program because it's, for them, it's very difficult to teach them enough programming that they can be impressed what they've done on the screen, right? Because they play games that are more expensive than Hollywood movies, right? Coded by 100 guys and designed by 300 people, I don't know. So it's, but having something that's in the real world really makes it interesting. So I find that I am kind of torn in this sense. I never taught kids that are younger. And when I was teaching at this school, I was told by the people who hired me, look, don't talk to them about Scratch, because they've been exposed to Scratch a few years ago, and kids at this age in this school, they think Scratch is just for the little kids. So, but then it was their first contact with, actual syntax. Scratch is great because it avoids syntax errors, and it was a little bit painful. Yeah. But, and one thing that's very challenging for me, I don't know how to deal with that very well, is the fact that we always see people who become really interested in this, and then some other people that are not so much interested. There was actually a paper a few years ago, a scientific paper, supposedly, by some British teachers. It was called "The Camel Has Two Backs." Have you heard about this? And their idea is that after they did lots of tests, and they discovered that although usually when you submit a random class to a test of math, you get a Gaussian, right? But if the subject is programming, you always have two Gaussians. And it doesn't matter if it's the first class in a computer science course, first day, or the last day. It's always two. And I've observed this empirically. I can't prove it, but have you seen this? Yeah. How do we deal with that? I don't know. I haven't been in a situation to plan a longer course, but probably if I had to plan a longer course and had to address this problem, I would probably do a multidisciplinary thing. Like, for instance, okay, so we're going to teach you game programming, okay? But not everybody that works in a game production is a programmer. Some people are musicians, some people are designers, and so on, and we are going to discover, you are going to discover what suits you better, what you like to do, and that's what we want. So the idea would be to give everybody the opportunity to learn all the parts, but then to allow them to focus on the stuff that really interests them. Yeah, I think this is a big challenge. Okay? All right, thank you very much.
Thank you very much. Appreciate you coming out. So we're going to release you to the refreshments, which are out in the lobby. You have about 10 minutes or so to kind of take care of things. Come back in, and we'll introduce the next two speakers. If you would like to give one of the lightning talks, please come sign up. Got 10 slots. Thank you guys very much.
All right, thank you very much. Oh, yeah, yes, sorry. Thank you. Hey. Yes, no, actually, yeah, I have one of these, right? Let me just, yeah. out of the way, and then I can give you a try.
You mentioned the Alan Downey book. I'm here with, do you know Jeff Elton?
Yes.
Oh, you know Jeff, okay.
Yeah.
Jeff is,
And the presentation thing for the lightning talks, that gets a little dicey because you have, in lightning talks, we have basically about 10 people who just kind of come up, put a laptop up, plug in, and then they talk for 5 minutes and they walk away.
Okay.
So that's what the lightning talks are.
That shouldn't be too bad at all. We have various connections, so we should be able to get that. Do I have 5 minutes to run?
You have 10 minutes, go, what's up, Chad? Oh, wow, hey, that's useful, right?
and I'm also board of DC hackerspace.
Is that right?
And I have a signed copy of Fab. You know, so it was a very interesting talk. It's like, yes, there's a lot of parallels there. I'm not as into the hardware yet as I should be. But, you know, I've put together a pipe talk and, anyway.
Sorry, I don't have cards here.
All right, well, you have
But anyway, I will send you an email.
Yeah.
Sure.
And if you know Jeff,
Yeah.
so.
Yeah, awesome. I love this area of the country.
You'll have to stop by and
I
see
will,
us.
totally. Yeah. All right, Tim, thank you. Thank you. Yeah, this is kind of a basic. Thank you.
That's why on the course I did wildlife and project programming. Thinking about someone that does not think about programming like scare me a little bit. Like teaching to read. I know it's very hard. I don't know how to do that.
Very striking. It's kind of a blending of yours and Carol and the same way it is. And hey, how are you?
Hey, nice to meet you guys. I love your books. Yeah, join the club. I've been talks for like
'Alright, so they have various types of dongly things to plug all stuff in.
Cool. Okay.
There's a gentleman who is not here, but he sits there and he wears a dark black shirt. He will come over and he'll fit you with the little rock star microphone thing, so you can pretend to be
Oh,
your favorite
good.
rock star.
Oh, good. For when that the music
Yes.
turns on, I can just
Yep.
riff. It'll be great.
Yep.
Okay.
All right, so I'll let you have peace.
Okay. Thank you.
If you need anything, do not hesitate to ask.
Okay. Yeah. Would you like one? It's a sticker for where I work. It's Lean Dog. Thanks. Yeah. I'm glad that you.
Thank you.
Uh-huh. so.
Excellent.
I have a tendency to use a lot of slides. I mean, with like just a picture on them. So
That's good.
I
to
feel like-
actually,
yeah, I think so.
because I either have no slides because I hate making them,
Oh,
or
really?
I do like the text thing, which
Oh,
I'm not
yeah.
doing this time. Like because everybody's just like, your slides are awful. I'm like, yes, I know, because my job, I'm not here to give you good slides. Like I'm here to give you talk.
This is really funny. Okay, so I like love making slides.
That's awesome.
But yeah, we should collaborate because I hate actually the other side, which is like it sounds like you're really good at.
It's like that's fine. Like I can put together, like because I'm subbing
Yeah.
for Wahan, like I literally put together my talk on the plane. Like I knew what I wanted to talk about. I knew what
Yeah.
projects I wanted to do.
Oh.
You know, so I was just like, okay, no problem.
That's
fine.
amazing.
But then I'm like, I'm scared, and I'm just like, I hate this. I have no creativity. Like I'm not creative that way. You
Yeah,
know? Like
yeah,
I'm
yeah.
creative
Because
other.
coding is creative for
Yeah,
sure.
and I'm a musician by training.
Oh,
which,
yeah.
Like, I spent 10 years as a music teacher before I ever,
Yeah.
like, did anything other than the code I did when I was little, like, with Logo.
Yeah, yeah.
So, you know, it's
Yeah.
like, I can be, but it's just, like, in this format, I'm like, I don't care. Like, I have the worst attitude. Like, I have an attitude problem is what is wrong.
You're prioritizing. Yeah. Yeah, hi. I'm Charlotte. Nice to meet you. Yeah. Wow, I've never used a mic before.
Well,
They're pretty cool, actually.
I'm gonna feel so loud.
it does allow you the ability to walk around, but some people are more comfortable just standing in front of the podium. So whatever I think works best for you.
Okay, yeah.
Which would you prefer?
Oh, I don't know. What is the least technical risk?
We're pretty good no matter which direction you
Yeah.
choose. This one here is just, it allows you some freedom, so you don't.
To like move around a little
Yeah,
bit?
you won't be just stuck
Time
here.
to the podium.
Otherwise, we are recording, so if you walk away
Yeah.
from the podium without this, you won't come through as clear.
Right.
Essentially,
Okay.
there's no harm in wearing it, right?
Yeah,
like,
I
you
guess
can
we could
balance
just
the
do it.
sound between the podium mic and that.
Yeah,
Okay.
absolutely.
Dude, I would wear
Let's
it.
do it.
Okay. So
Okay.
this just goes around the back. It's like the reverse glasses.
Oh, okay. So like behind.
Behind your hair would probably be the easiest,
okay.
most comfortable for you. And then, if you bring it up over your ears, we can kind of bend it and shape it for you.
Okay.
I'm going to flip it on now, but you won't be coming through the sound system
Oh.
until we have the cue that we're
Okay,
ready to
that
go.
would be good.
And so you can just clip that into your pocket or your belt or wherever you're comfortable.
Okay. Cool.
Yeah, a lot of people just do that. And it's
Okay.
on now, so you don't have to.
So don't say anything that would be bad.
Well, it's too late. We already got you.
All the secrets. Darn it.
And
Yeah.
in your presentation, if you have presenter notes, it'll show up on your laptop most likely, and that'll just let you know what's on the projectors.
Okay. Thank you very much. I appreciate it. Cool. Yes. Yes. Hi. Yeah, that sounds good. Thanks. It is so true. I do. Yeah, I'm really into that.
All right, so we're about to get started. The lightning talk board is filling up. That's awesome. Excited by
Here.
that. Our next two talks, we're going to just roll right through. The first one will be Charlotte Chang. She'll be talking about climbing rocks and coding blocks. Rumor on the street is she likes high fives, so keep that in mind for later. The next speaker will be Jessica Ingrassalino. She's the chairman of the Education Summit this year, and she'll be talking about teaching diverse populations. And when Charlotte's talk is over, we're just going to migrate right to Jessica from that point. All right, and I'll see you guys when Jessica's talk is over.
Okay, great. Thanks. Wow, this is really loud. All right, so I guess the first thing I want to do is if everyone could give a round of applause to everyone that organized PyCon. Like, this is amazing. Yeah, it's a lot of work. They donate their time, so yeah. A little bit about me. I actually have worked in tech for about 14 years in a lot of different places, primarily doing consulting, but I've worn a lot of hats, BA, business analyst, area manager, UX, QA, developer. and of course the consulting side of things. More recently in my life, I went to a full stack web development boot camp, right, called Flatiron School. It was Ruby on Rails. I don't know if I'm allowed to say that here, but I hope Ruby and Python are friends. I hope we can still be friends. I also recently started teaching middle-aged school girls robotics with a nonprofit called Her Ideas in Motion, and it's this combination of like learning how to be a developer and teaching middle school age girls that really got me thinking about teaching and learning. I work for a company called Lean Dog. So Lean Dog is located in Cleveland, Ohio. You might have heard of us because last year was a big year in sports. I don't really follow those things, but apparently it's a big deal and a lot of people care about that. Our company is, as you can tell, on a boat. It's actually half a boat. It's a barge, and we do we do two things. One is product design. So we have like a studio that does. We have developers and designers that sit with the client and work with them and build something. And then we have an organizational design coaching side of the business, which is actually where I am. And I go to client sites and coach them on various agile, lean, and systems thinking techniques. Not only are we on a boat, but we also have boats and kayaks. So sometimes when I'm not working, I take my dog out on a kayak. So that's what we're doing there. He doesn't really like it, but it's okay. I also really like high fives. So yeah, let's go. Nice. And here, you get a sticker for that. All right. I have a lot more stickers, so if you guys want a sticker, all you have to do is high five me. Okay. Okay, so you might be wondering, what does rock climbing and coding have to do with one another? So when I went to boot camp, the very first day, within the first hour, we were learning command line and GitHub because we had to get our assignments done. And needless to say, I felt like this. Okay, so at this time, I already been in tech for like over a decade. Okay, so it felt sort of weird to feel like this. And I did a little retro analysis to think about how do I feel less like this, or at least how do I laugh about this more, and how do I learn more effectively? And what I figured out is that when I'm coding, sometimes I'm thinking really hard about things, I'm investigating, and then I'm falling. Pretty soon, I can't tell up from down. And when I land, I have no idea where I am, and there are a lot of strange things happening. This, of course, is a metaphor, because when I'm learning to code, I couldn't see the forest from the trees. So why does this happen? There's a lot of reasons. And later in this talk, I'm going to talk about that and how, when I got stuck, how I got out of that. So overarchingly, what I found to help me is finding perspective. So when someone's learning, they don't really have context, which means that you sort of get lost. So show of hands, everyone remember this from high school, compound microscopes, right? Okay, so you remember you had your high school teacher, and they were like, okay, you're using like an onion cell or like your cheek cell, whatever, right? And they're like, okay, you have your slide, put it underneath and in the tray, whatever, and start at 1x, right? And then, like, you got smart. You're like, oh, I don't need to start at 1x. I could just go to 100x, right? Like, why would I start at 1x if I know I'm going to 100x? How many people did that? Yeah? Okay, and how many people totally could not find the cell at 100x? Yeah, exactly. So that's what happens. You basically need to start at 1x so you can focus on the thing you're looking at, move to like 50x, right? You're getting closer, but at least the thing you're looking at is still in view, and then move to 100x. It's also, sometimes when you're looking really close, it's really hard to find that semicolon that you've missed. That's really frustrating. So the other thing is, when you're new, when I was new, and I'm still new, you get signs and directions, but you just have like no idea. I just had like no idea what to pay attention to. Should I be looking up? Should I be looking over there? What does this error message mean? It could mean a lot of things. So I'm going to today share my stories about learning to code, and hopefully some of you will find some inspiration in this, and in your own practice, think about it, or in your practice of mentoring others, think about it. So these are the 7 things that we're going to talk about. The first thing is breaking down the problem. So where is one of the scariest places to be? Here. Empty text editor, right? It's like, oh my gosh, I'm going to create this amazing thing. In climbing, it's also like that. At the beginning is pretty scary, and sometimes climbs are actually arranged to be awkward and hard at the beginning. The other thing is, on top of that, I want to be this. Like, I want to be this like really smart person that can like figure everything out. But in reality, sometimes I'm this. Like, I'm just trying to get the stick through the door, and I cannot figure it out, right? Let alone the computer. So the thing is, hope is really hard. There's a lot of emotions involved when you're starting out, and it's a really scary place. So I'm going to discuss 2 ways in terms of how to start, right? So there's jumping in versus planning. So jumping in, it's great because you fail the fastest. It also widens your breadth of experience. And in my experience, this approach works well for those that are confident. And so what do I mean by confidence? I mean knowing. And knowing comes from having experience. It comes from exercising your skills. And it comes from knowing what to do when you don't know what to do, right? It comes from understanding where your safety nets are, if you have fail-safes, if you have backups. So a lot of this content, we'll address a lot of these throughout the talk, but the first thing I'm going to talk about is planning. So if you're not confident, you can take a step back and plan. I found this to be super, super helpful. It allowed me the time to think, and allowed me the time to analyze before I actually wrote a line of code. It separated the act of doing from the act of thinking. So what this means is it gave me the time to think about targeted failure. Where in my plan am I going to fail? So sometimes when you go climbing, you can see this happen. You'll see somebody, you'll see a group of people, they'll look like this. They're not like doing some crazy dance move. They're actually planning out the route and how they're going to climb it. And they're like mimicking it, right? This allows them to understand sort of where they think the hardest problems are going to be. It also allows them to plan out where they can take a rest, for instance. So in this Devil's Tower, you'll see that there is this horizontal line. Okay, like resting there, the challenges at a horizontal versus a vertical climb are going to be different. This happens in your code too, right? So whether or not you're climbing the Devil's Tower or you're trying to tackle Tower of Hanoi, understanding the steps that you have to go through allows you to think about the preconditions, your current condition, and your post-condition laid out before you even write a line of code. Something that I like to think about when I am at client sites is separating this idea of ready to discuss, ready to do, and ready to deliver. Again, we want to separate the act of thinking before the act of doing. So I'm going to argue that problems are problems, and we're going to run into them no matter what. So I want to bring ahead any of the problems that I'm going to run into as soon as I can. So I don't want to plan for everything, but I don't want to not plan either, right? So this is like a lean concept. So in IT, departments are often asked to not only provide technical solutions, but also eliciting what a request or a ticket actually is, what a product owner means, what the user value is. And this is usually after she or he has started coding. If you've ever worked for a startup, a lot of times they even give like phrases like, make it pop, or I want it to wow, which of course is like extremely hard to measure. And there's probably multiple definitions of that as well. This holds true in climbing as well. So if you can imagine, if you're trying to figure out what to do when you're climbing, you're fighting gravity all along the way, right? As opposed to planning it out at the beginning, and then it's a lot easier to figure out what your next move is because you've run through it in your mind once, at least once. That's gravity. And so in this case, for IT, the gravity is trying to hold in all the information of the high-level goal you're trying to figure out, all the emotion of not trying to failure, trying to remember all those best practices that someone taught you, not wanting to let anyone down, and that's what gravity is when you're coding. So if you plan, at least it can set aside some of that gravity so that you can focus on the moves that you're trying to make. So the idea here is to conserve energy. We want to reduce the cognitive load by focusing on one part of the problem at a time. So this is just some sort of agile technique. Basically, one of the ways you can do this is you have a requirement, right? So you have a story requirement. In the requirement, you understand the business problems and goals. From there, you can move down into acceptance criteria, right? So you're starting to define the definition of done. So when is this business or user goal achieved? What is good enough? Right? You can move down deeper into acceptance tests. So thinking about the end-to-end expectations, the preconditions, and the post-conditions. And then tasking. So once we've now declared the scope of this, we can now technically task. I found this super helpful for me. I could literally list out the tasks that I needed to do to complete a test. It's essentially a roadmap. And if I do it with other people, that means that there's a common understanding within the team and a clear approach end-to-end with a goal in mind. From there, you can pseudocode. So you're starting to think about your technical approach, and then, of course, the coding. At a high level, I'm trying to separate out the what from the how. So I'm not going to go into that a lot, but what I'm trying to show here is that I really want to be diligent and efficient about what I'm thinking about at any given time, and I don't want to think about it all, because that's too much. So this all increases our confidence because we feel safer, right? We agree on the goal, we understand the goal, we understand the approach. And I bet our code readability is going to increase because of the thinking that has gone through before you've even coded. And I bet you also the team velocity will increase because of the shared context. So just to reiterate, jumping in is less efficient, I find, for newer beginning coders, or at least for me, because I was unsure and unaware of any divergence, right? I'm unable to prioritize effectively about a viable solution or option. I waste energy investigating. And also, I'm not really good at hunches. I haven't learned that yet. It's also less efficient because of backtracking. I go farther down a course, I'm more likely to be on a wrong track, and also I'm more likely to go further down that course before realizing that I'm on the wrong track. It's also less efficient because, as a new person, I'm still trying to figure out skills. So if I'm off track, it's harder to pull myself out. If I make a wrong step, I don't have as many options to think about in my tools to know how to pull myself out of there and how far back I need to go. Lastly, it's also less efficient because it's the increased number of cycles that I'm going through with all the things above. So the goal here is the plan, right? Separate the act of thinking from doing and task out a list of technical to-dos. So we've learned to break down the problem. So what happens when things don't go the way you've planned? So the second tool and technique that I used is to keep calm and code on. So this is Lake Erie. No, it's not. Sharks are not in Lake Erie, just so you know. So climbing can be dangerous, yeah? Well, coding can be dangerous too, right? So this is a report from the Standish Chaos group. This is from 2015, and This is an organization that polls software projects once a year, worldwide, across industries and domains and sizes, and asks how successful they are. So success is judged by being on time and on budget with a satisfactory result. Challenged is delivered, but something had to give, whether it be budget or time, and then failure is they just did not deliver. So failure is real, right, in our day-to-day coding lives, and we have to deal with it. So how? So my question is it real? Because in Agile, they talk about planning for change, right? And one of the ways that we do this is by breaking down requirements into smaller units so that we can start to track work. So what if we extrapolate this idea and to say change is real rather than failure is real? Right, so if we start to think about failure in terms of change, I like to group into two groups. One is expected change and one is unexpected change. So in climbing, they even have like articles and discussions about falling or failure. This is an expectation, and there's even techniques about what to do and how to get better at falling or failing. But in coding, it's a little bit, I would say, a little bit more difficult because developers are really smart. You want to seem really clever, and there's even memes about this, right? So it's not like I'm making it up. Does anyone know who this is? Yeah, who is it? Do you remember? Yes, Sandy Metz. That's right. I know. Yeah, Ruby. I know. Okay. So, I went. I had the privilege of going to a object-oriented programming class that she gave, and it was great. So she talked about a sort of a change in thinking about being, a great programmer. She said, forget about being clever. Forget about being terse, right? And by terse, she meant number of lines of code or badge of honors. She said, use brute force. Don't think about polymorphism. Just use an if statement, right? She's basically saying similar things to Kent Beck, right? So just make it work. Like, I don't care how you do it. Just make it work, and then make it right, and then make it fast. Another technique of changing this idea of failure to expected failure is red-green refactoring, right? So when you write a good test, you know something's going to break. You expect the failure. That's how you know you've done a good job, right? You make it pass, and then you refactor it under green. Another technique that I like to use is ping pong programming. Does anyone, show of hands, anyone do this? Yeah? Okay, so I saw one hand. So essentially, in pair programming, ping pong is where one person writes the test, and then the other person makes it pass. So again, you're expecting a failure, but the other person gets to make it pass, and it's sort of fun. So yeah, that's another technique you can use. So the other type of change or failure is unexpected. But again, I want to move that concept into expected changes and failures. So in order to do that, we have to think about something that we sometimes don't want to think about, which is maybe how we grew up and how our society taught us. So we were taught that failure is bad. During Luciano's talk, someone mentioned failure, right? This is part of the conversation. There's also something that happens where there's like an attribution to like our intrinsic self. So it's not even that failure is an isolated thing. Somehow, that failure means I'm dumb. So wouldn't it be great if we could just move this idea to failure is just feedback, right? So it's not that I'm dumb. It's actually just like I tried something and that didn't really work. So that's a big mind shift. But luckily, there's a lot of people talking about failure and why failure is important and how you can succeed and how you can only succeed through failure. So success isn't a straight line. So if we know that success isn't a straight line, then we should set our own expectations that there are going to be curves and twists and knots all along the way. And further, if we don't have that, then I think that we should challenge ourselves to really wonder if we're trying hard enough, if we're not running into those things. In climbing, there's a concept of you climb to fall. If you don't fall, that means you're not climbing hard enough. And I challenge that we should be doing that too as programmers. We should be expecting ourselves to fail. Now, I do want to just make a little note here that I'm not saying try everything so hard that you're just like failing all the time and you're like freaking out. So there is this idea of eustress and distress, right? So eustress is this idea of having positive stress. And what we want to do is that's the target we want to hit. Okay, so the idea here is that you choose problems that are just outside your reach, that are you still have to learn, but they're achievable, right? And so, you know, these two psychologists basically studied that if you choose either two problems that are too hard all the time and also problems that are not hard enough, people will be in distress. Okay, so learn what works by setting expectations, plan for failure, adjust your mindset, take a break, recognize helping versus hindering. So the next thing is walking the Gemba. Does anyone know what Gemba means? Yeah? Okay, so it's from lean manufacturing. And it is basically it means walk the line. So it's from Toyota, okay? So this is really hard, right? Because Star Wars teaches us that there is basically no trying. There's just doing or not, basically. But this doesn't mean like Luke Skywalker just got thrown into that final battle with Darth Vader. He trained, right? So he trained all the time. So we need to pick and choose our failures, meaningful feedback, right? The training is us selecting when and how we're going to fail so that we can learn what to do when we encounter that in the real battle of Darth Vader. So what I mean here is practice. Practice in your code, right? So try katas like exorcism.io by Katrina Owen. Go to hackathons. Find something that you love, right? And work on that. Get experience, improve your fitness, gain skills, increase familiarity. So the fourth tool and technique is Kaizen, which is continuously improving. So when I think about this, I think about measurement and mastery. Okay, so why is measurement important? Do we have any runners in the audience? Okay, right. So the people that run, you might run on the street or in the trail, but you understand the concept of running on a track, right? So there's a track at a certain distance, and there's this idea of splits. Okay, so let's say I'm doing 4 laps around this track. Well, every time I go around, I understand what my time is. That's giving me feedback about how fast or slow I need to run in order to complete the four loops, right? So we can do this in our own coding practice as well, right? And we can see how much work we get done. We can also do a Pomodoro. Does anyone use Pomodoro techniques? Okay, cool. That sounds like a lot of you. So take a break after X amount of time, 25 minutes, and see how far you get. Give yourself a little refresher. Someone last night at dinner asked me, I'm really trying to convince my, who's in med school, she's not a coder, to do Pomodoro, but she's always like, no, I'm really in the middle of something. So I gave him 2 suggestions. One is to either increase the time of the Pomodoro, so let's say it's like 45 minutes instead of 25 minutes. And the second thing is to offer up something that she really loves. Thank you. So for me, it's planking. I know that doesn't seem like really fun, but I'm really lazy, and I don't want to have to work out after work. So if I can just like incorporate this throughout my workday, that's perfect. Okay, the other thing you can do is measurement. So just do a Kanban, see how much work you get done, measure it every so often, as long as it's a regular cadence, and then you can see if you're getting better. Also doing a retrospective, right? Just do a little retrospective with yourself. See what makes you happy, what you're finding difficult in that last period of time, and things that you find puzzling. Take note of what you know, what you don't know, and what you're trying to get better at, right? So that's another way to measure. So does anyone know who this guy is? Yeah, that's right. Who said that? That was awesome, yeah. Okay, I just learned about him. So he won the Nobel Peace Prize in 1965, and he basically was able to explain really high-level physics concepts at a really low level. So you all should look him up. And he basically says that we actually don't understand we don't know how to master something unless we can teach it. So that leads me to actually mentorship, which I think is really the third thing in terms of improvement. So there's non-proximal development, or shuhari, which is this idea of I do, you watch, you do, I watch. And there's many ways to also extrapolate this. There's Edgar Dale's cone of learning. So the idea is that you want to try to get people doing things because they're going to retain it more. All right, so I ran out of time really quickly. Maybe I should end with this. So another thing is, like, when you're speaking to new people, just go back to basics. Think about similes and metaphors, right? And when I looked up a picture, I don't even understand this picture, but I think it's hilarious. So I guess a simile is this person that is like a cow, and a metaphor would be this person is a cow. I'm not sure. But yeah. And actually, I do want to end with one thing, and I know what I want to end with. I want to end with Project Aristotle. So a while back, Google basically wanted to find out what the perfect team would be, right? And so in the Google way, they assessed, okay, is it experienced people, not experienced? Is it like certain genders? And what they found out was that actually all it is good teamwork. It's psychological safety. So being nice to one another, what we all learned in preschool or kindergarten, is what makes teams effective. And it's going to help your own learning process, being kind to yourself and kind to others. All right, thanks, sorry. All right, so I ran out of time, but that was it.
If I wander. I'm slow. Is that okay? Okay. All right. Okay. Sure. Hi. So I am speaking today because Wahab Olalaken, who was originally slated for this spot, found out and told us last Thursday that his visa was denied, unfortunately, which left us with an open spot. So typically I would not take a spot in the program that I'm designing, but given the kind of very quick need to do something, I wanted us to be able to still have a talk. And I think that given the talks that we've had and the talks that we'll look forward to, I can contribute something relevant. I'm hoping that that is the case, because a lot of the problems that have been brought up are about addressing some of these complexities that arise in diverse classrooms. So your perspectives, how many of you would consider yourselves teachers before coders? Like, you know how to code, but you're a teacher. Okay. And how many would consider yourselves coders who fell into teaching? Like, okay, cool. So we come at this from different perspectives. As a teacher, I'm a self-taught coder. I have been teaching since I was 19, but I only learned to code 4 years ago because I needed to do it for my job. I was a music teacher for 10 years. I still teach private music lessons, but I transitioned out of classroom teaching and into tech teaching, and now I work in a community college environment where I work with children of all abilities from the ages of 10 to 17 in the same room, and I'm developing a workforce development program for veterans, adults with disabilities, and what we might say mainstream population of students. So given my background, I come with a set of ideas and circumstances and thoughts that inform how I think I ought to move forward. So the thing I've learned most from all of my teaching experience is that life is diverse. And oftentimes it's easy to forget that when we're looking at how do we make our classrooms more diverse? Well, we look around at all of the different groups we participate in every day. And I don't just mean classroom groups. Groups like we ride the bus. We walk into our office building and we're interacting with a variety of different people. We walk into the grocery store. So we have a variety of different people around us all the time. And preparing our learners in our classrooms for this diversity is, I believe, critically important to their development as people, as programmers, as learners. So what did I try? Well, the classroom that I've taught in for the past 2 years is a Saturday class that, as I said, has students who, I have one student who is a special needs student. He's 16, his ability level is that of about a 7-year-old, but he wants to code, and he loves computers. I have in this class of about 16 students, probably 14 of those students are kind of on the average where you'd expect someone to be for their age. So I have 2 10-year-olds who can't control anything that comes out of their mouths. I have a few, but not many, female students who are actually quite mature and very helpful to the other students. And then I have 1 or 2 students who insist on retaking my class. And so I have to develop curriculum and something to help them move forward, aside from helping their peers, because that teaching piece is a learning piece, but also how do I design something that builds their skills. So these are the things that I tried, and what I learned, or what I and am continuing to learn, is that I'm one person, and being one person, I can only do so many things in that classroom environment, and I can only get around to so many people so many times. And this is a pretty realistic situation, because all of our students come to us with these different expectations, values, skill levels. So what do I do? What are my concerns? One of my concerns is the materials. So how do I have the proper materials at the proper levels to provide this education for my students? Another concern that I have is access. So I may have students who have tons of cool computer access at home, but some of my students might be on a Windows 7 machine. Ha, ha, ha. Some of my students might have, might be on a Mac. Some might have a new Windows 10, slick laptop. Some, not many, but some are working in Linux. So, I have all of these things. How do I deliver an education that can extend beyond the 2 hours I see them every Saturday? These are my concerns. Now, currently I'm creating a program for veterans, adults with disabilities, and persons who would be considered able in the regular population. So the first thing that I'm thinking about as I'm creating this program is, how do I evaluate the strengths and needs that will come into that room? So this is obviously something that I think extends beyond teaching code, but is really relevant because there are many people who want to do this, and I know as a teacher I want to be able to deliver what I consider to be really enjoyable and fun in an enjoyable and fun way. So I started taking a look in the research at the strengths and needs of veterans, and the VA of the United States reports teamwork, duty, sense of follow-through, starting to finishing. These are all just some of the key qualities that veterans come back with after they've served in any kind of service situation. These are strengths that we can build upon. Similarly, persons with disabilities have a lot to overcome. And so there's a persistence, there's an ability, a tenacity for a person with a disability who, if they are blind, they have to find their own accommodation a lot of the time, because we don't live in a society that easily and readily accommodates. So these individuals are individuals who are who have these strengths, but that also means they have some needs. You know, so something that we have to think about as instructors is the potential that our veteran populations may have a trauma history, or that even some of our learners may have a trauma history. Some of our students are coming to us from potentially chaotic environments, abusive environments, environments where they've had to either fight to survive, or in a battle situation, perhaps they're dealing with some post-traumatic stress disorder that may affect how they experience stress in the classroom. So these are things that as instructors, we do need to have an awareness of. And there are, you know, ways to address this. So the first thing that I have done and I'm planning to do is access everywhere. So when I select books, when I select software, I select things that they can log into in multiple browsers and multiple settings. If they don't have a computer at home, they can go to the library, they can go and do whatever work that they may want to do, whatever enrichment they may want to do. They can do that without needing a special program or a special software or anything that might prohibit them from gaining extra learning or more access. It also means access to books, and there are programs. O'Reilly has the Safari program with the books. PACT has Mapped, which allows for some flexibility, and more publishers are seeing that they can kind of put their content together in a way where I could select a book and say, this is our main textbook, but since you're subscribing, or since the school is subscribing, if you're advanced, go check out these 2 books. These will be great. And if you're struggling, check these out, do these exercises, talk to me. So looking for flexible, accessible solutions so that way that people can access their education wherever they are, I believe is a very critical component to success for diverse individuals, because we don't always know that they have access or not, or where they have access. Some people might just have access on their mobile phone until they get to your classroom. So it's really important to figure out how to make this happen for these students. Differentiating the instruction, saying, okay, as an instructor, I know the material. I know the lay of the land. I'm a programmer. I know 6 awesome online IDEs that I can use to help the students. And I know that for a student with a disability, this one might be preferable than for a student who is very advanced in data science. They might want to try something else. And yes, I do have a list of things, and no, I'm not going to name too many products. It'll seem like I'm dropping product placement everywhere. But I think picking and choosing wisely, so that way that the students have this access and levels of instruction that meet them where they are, will help them move forward. And these are things that they are tricky, and at the same time, I have done them in my classroom, so I know that they can work. Building learning communities is a critical component of building out a program for diverse learners, because people, the safety aspect, as Charlotte just said, in the Google project, the big thing was psychological safety. So in my classroom, building a community inside of that classroom where the students feel safe, they don't feel overly criticized because they cannot do a specific code thing right away, allowing for creating a space where they can have conversations is definitely key. And I think that when you're dealing with individuals who may have trauma histories, that can be a little trickier because you are asking them to perhaps deal with different kinds of stress, different kinds of fear in approaching something. Maybe because they don't want to fail, because they have a history of failure means something very bad will happen to me. So this is a consideration, and there are absolutely techniques and ways to deal with these kind of personal skills and build them in the classroom. There are two I'm going to mention. One I will mention is Crucial Conversations. There's a book, there's like a whole training deal with it, but honestly, you can read the book and grok the major concepts, like that you could then begin to kind of employ. The one that I find significantly more effective, and I've given more broad talks on this in the tech community, is something called dialectical behavioral therapy skills. And it comes from a place of being able to acknowledge where somebody's coming from, validate why they're feeling maybe frustrated. So if you have a student who's extremely frustrated, is like ready to give up, saying to that student, I understand you're frustrated, what's going on? Why are you frustrated? Pulling that person back in by showing and meeting them where they are, and then saying, okay, what can we do together to move forward? There are a lot of tools online about this. You can just search DBT skills, and you will find all the things, and it's a great means of communication. It's something that I've been working with and in for the past 6 or 7 years myself. So I've found it to be a really great tool in diffusing my own personal situations where I feel frustrated, but I need to communicate something important to somebody who I can't tell off, basically. So, I've found it to be very helpful, and I think that wrapping these skills into the class, so it's not a separate thing you do, but wrapping them into the class as a part of how you as a teacher interact, and then allowing the students to see that modeled at any age, at any range, is extremely helpful for them because they can start to learn how to interact with other professionals they may encounter when they leave. And this, of course, the program I'm creating, I have the goal of moving the students into internships. And I can't move students into internships who can program really well but can't talk to people. It's not going to happen. I mean, I am setting them up for failure, and it is not a responsible educational thing to do. And I realize this. My teacher self knows this. So I think that as much as programming skills are very important, as we can talk in this room, there are hundreds of different ways to do it and do it well. And we have evidence of that. And the personal skills, I do believe they need to be incorporated into how we're doing this, so that way that when we're teaching diverse populations, we're enabling them for success beyond the programming skill set, which is pretty critical, at least in the New York startup world where I kind of operate with this particular population. So that's really it. I would love to take questions and have a discussion with any remaining time that I have left. Any questions? Yeah. Yeah, absolutely. So in my time as a public school teacher, before I went into tech, I taught public school music for 10 years in New York City public schools. And something that I would do and is to pass out a questionnaire. And in that questionnaire, not to, try to go too deep and psychological on them, but things I like, things I don't like, who am I, where do I come from, like just kind of descriptors so I can get a feel for, is this person, what in between the lines, are they telling me that they're responsible for taking care of their family? Are they telling me they're a single mother with 3 kids? What are some, maybe a question to put on would be, what challenges do you think you might face in completing classwork? Or, so let them self-identify to you, giving them that opportunity, hey, wait, I have 3 kids. I am a single mom, and I'm taking classes at night, and I work 2 part-time jobs. So that student, and then you can engage in conversation with them in a way, like rather than saying, well, where's the work? Your team's counting on you. Yeah, they get that, right? Like, they're well aware, and their 3 kids are hungry, and their bosses are pissed, and they're just, they want to learn. So being able to do a problem-solving validation mindset, hey, Judy, I know that I know that you seem to have a lot going on. What's happening? Get the story, validate, yeah, I really understand. And, some of your teammates have been kind of concerned with if they're going to get this project done, what can we work out to make sure that this works for everyone? Right, so it's like a problem-solving mindset. So listening, validating, yeah, I totally hear you're stressed, and we still have this problem on the table, right? It's like, and the key thing that I've always found in this kind of work is conjunctions. You will notice people use and or use but often. Well, I know you have this happening, but we need to get this done. People make it polar, and it's not polar. Judy wants to learn, and Judy has 3 hungry children. It's not really an option. We can make it not an option. We can make it so Judy can't learn because of her 3 hungry children, or we can say, Judy does, and so. And if you listen to people talk, you will hear more often than not the conjunction but used rather than the conjunction and, because we live in a polar society. So these are some things I've noticed, and those are some ways that I've used to try and communicate with people who are having difficulty, and at the same time, I need to solve a problem with them. Hopefully that's something helpful. Yeah?
Yes, what musical instrument did you teach? Is question number 4 instruments. And this question number 1. Question number 2, do you see the connection between musical instruments and programming?
Yes to all. So I taught band and orchestra, and chorus, and piano, and music technology, because in New York City you do everything, you do nothing. My professional instruments are violin and viola, and currently I teach private violin and private trumpet. It's a very interesting situation. The connection between musical instrument playing and teaching programming is like so natural. People asked me, well, how did you get into software that's so different from music? And I'm like, dude, I played the violin. I locked myself in a padded room with no windows for 8 hours a day for 3 years to practice violin. It's not that different, okay? It just isn't. I didn't have a Pomodoro. I had friggin' 2 vending machines with Butterfingers and Diet Coke, right? But so, the discipline of saying, this is a Mozart concerto, but you're not gonna learn the whole Mozart concerto. And our students, it's the same way. We're not gonna teach them all of Python ever, but I can teach them to write a function. I can start there. And when I play a Mozart concerto, I start with the first measure. I don't start, I'm not like, I'm gonna play the whole concerto, dude, fuck that. Like, it's not gonna happen, So I'm gonna play the measure, and then I'm gonna go to the next measure. And then I'm gonna put the measures together. And then I'm gonna have a line, and then a phrase. And I feel like coding is really similar, actually. It's such a similar process. So yeah, I absolutely feel that relationship pretty viscerally. Yeah? So I don't yet, because this is a program that I'm building with for the fall, for a start in fall. So I don't have any yet, but it's something that I'm going to actually be incorporating in the parts. I'm setting up my classroom basically like a mini startup, and we're going to have kind of stations, and I have no idea if this is going to work. So. I probably ought to, just because I have a degree in educational research, and I could probably use that. It would have some use. It would make my debt worth it, right? So I probably ought to. It might be interesting to follow up with that. So thank you for the suggestion. And I think I'm out of time, but thank you very much. And Chalmer is going to give us the next instructions.
Thank you, Jessica. All right, so first thing, for all of the speakers who kindly volunteered their time to prep and to come out here and to offer their insights in Python and education, we have a small surprise for those folks. The BBC started a program a number of years ago to try and help drive education, and they created a thing called the Microbit. The Microbit Foundation has carried on and is continuing that particular work. And the Microbit Foundation has kindly donated a number of microbits. Nick Tollervey muled those things over here, smuggled them across the border, and has given them to us. We have a number of them to give out to each of the speakers. So if the speakers could see me later in the day, we'll make sure you get your microbit, right? With that, we're going to transition to the lightning talks portion of our schedule. We've got about 9 folks who are kindly volunteering to kind of do a talk on the spur of the moment. The talks will be 5 minutes long. In order to try and maintain pace, try and make sure that when Minal flags you down and says stop, that you stop. If you stop in mid-sentence, that's even funnier. So yeah, let's do that, right? You don't want us to drag you off the stage. We're going to make Jessica do that. I'm not involved in that kind of thing. Yeah, right? So what we're going to end up doing is we'll have someone here, and they'll very quickly plug in their stuff, and they'll give their talk. We'll have the next person in line basically staged right there. So when that seat next to Minal gets empty, and you are the next person in line, come up. I will try and announce who the next person is so that we can keep this thing rolling smoothly. All right? So. No. We don't do that. Are you kidding me? Actually, we have a VGA connection. I think we have a DVI connection, and we have an HDMI connection. Right here at the podium, they should be ready to roll. You just plug into the one that you need. We're going to start off with Anthony Shaw. He'll be talking to us about running a Learn to Code initiative for a corporate workplace. From there, our next person will be Marcus Sherman. We'll be doing Python language immersion and education. Next after that will be Al Swigert. And when we kind of move folks through, I will introduce the people after Al, etc. Okay. Question?
I don't suppose anybody has a mini HDMI connection.
There's someone who does. That's the education community at work, right there. All right. You ready, sir?
Hey everybody, I'm Anthony Shaw. I work for a company called Dimension Data. I'm based out of Sydney in Australia. And I'm going to talk to you as quickly as I can about what I've been doing over the last few months. So up until very recently, I was in research and development as a development manager and a reasonably unsuccessful coder. And late last year, I decided to move into learning and development, which was a big shift. A lot of people thought I was a bit crazy, but it's been a really exciting adventure. The first thing we did was try and convince the company that coding skills is actually going to be one of the biggest I guess, drivers for our success in the future. So we're an IT company. We sell a lot of hardware. We do a lot of network integration. And we have 8,000 employees who do technical support. So introducing basic coding skills to that will actually make a significant difference to the business. So I kicked off a program in December, late last year, to basically try and convince as many employees as possible to learn to code. So what we did was, first of all, we focused on why. So we sent out this infographic to all of our staff. And point one is like a short video talking about why you should learn to code, what different languages are out there, and what kind of benefits, what the experience is like when you learn to code. So just trying to go like actually convince people to do it first, instead of just saying, okay, go and take this course and then you can learn to code. The second part was a course that we've been using, which Michael Kennedy developed, a Python Jumpstart course, which has been really successful for us. And then the third part, which is actually really important, was that once you finish the course, we ask people to take like a selfie, and then they run a Python script, and it basically like they put a message across the selfie, and then they share it on our social media internally. And the idea with that was just to show people how, okay, you've done it, well done, here's some success, and they kind of share their success with their colleagues. And that actually made a huge difference in terms of adoption, because people internally saw all these photos flying around of people that had suddenly learned to code. In terms of the demographics, only 5% of the people who took the course were from like a kind of software, had that as their actual job. Around half of them were technical, and the rest of them were from all sorts of different professions. We had 30 people in HR, we had people from finance, people from legal, so like all different job roles across the company. Let me show you the next one. This is like an infographic we just pulled out for this month. You probably can't see the numbers, but I read out some of them. We've got 2,000 people now registered on the course, and that spans across, I think it's 42 countries. The most successful country we've had has been Thailand, which has been really interesting. But yeah, some of the lessons from running this project was that people's feedback to me was that they weren't familiar with the things not working. Like when you learn to code, if you learn at a really, really early age, you're kind of used to just bashing around and just making it work. I think when people are used to using desktop applications and things are reasonably intuitive, but when you start to learn to code, there's a lot of sort of like, this is an error, this is the feedback, and they think it's actually them, that they're not good enough to do any coding. So one of the things I think we tried to set really early on was trying to set simple examples and then go back and refactor. So like, this is how you would do it in the easiest possible way, and then go back and then explain the points, and then teach people to refactor. And then the other thing was to focus on the reward as well. So we basically broke the course down into very small chunks. You get a working application each time, and the most basic one took about an hour to finish. So this is where we're up to, and hopefully we'll get more and more people to do this. We've got 30,000 employees. My goal is to get to 3,000 people registered on the course by the end of September. So yeah, that's it.
Anthony, thank you very much. So after Al Swigert, we've got Dan Posmanter. Hopefully I didn't mangle that. He'll be talking to us about philosophy for children and programming. Go ahead.
Yeah. My name is Marcus Sherman. I'm from the University of Michigan, Department of Computational Medicine and Bioinformatics. Just a quick remark on Luciano's earlier statement. I think the thing that clearly separates natural coders from people that don't code yet is that instead of the fear of failure, we actually embrace it simply because we love that aha moment when we finally found that semicolon that we were missing, or that if statement that was messed up, or whatever. So I think that's the clear thing. We love getting over those. In any case, just a quick raise a hand. Who here has been a self-taught coder? Yeah, it's actually a really important skill. This is like Stack Overflow is like our home page. In any case, I came from a biology background and got into bioinformatics later on. I came from like this farm podunk school that didn't even know what bioinformatics was, and then I went into University of Michigan with the full ride for that. So it's really exciting, but there's a huge gap that I had to get past. And one of the biggest resources that I used was the Talk Python to Me podcast. Does anybody listen to that? Raise a hands. Michael Kennedy is like an idol for me simply because he has all these contacts with subject matter experts. And Luciano, Carol Willing, they were all guests on the show. And I actually used this Lie group. One of my main resources is Fluent Python that I teach out of. But in one of his segments, he's talking to employers about what kind of skills are they expecting out of people when they want to hire them. And I realized that there's this huge deficit in academia where people, they know how to do Python, they know how to do R, they know how to do all these other languages, but they only know it ad hoc and it's spaghetti code through and through. It's nothing reusable. Yes, they're the top tier research. They can do great nature papers and science papers to get this research done. But as coders, when you get done with your PhD, if you plan on going into industry, they don't have those necessary skill sets, and there's a huge learning curve after they've graduated to pick up industry standard techniques and conventions. And this bothered me because even though I came from a biology background, I've always been a coder. I started with the 2E, the green and black screen. I started messing around with Oregon Trail before they had color. Like that was where I started, and I love that. I love changing the color of my DOS prompt. I loved messing around. So I wanted to see that skill set in an industry that was grossly deficient in these skills. So I started the Python Language and Immersion and Education group, which was meant specifically to teach people in education and academia industry-level skills, industry conventions on how to code. And we brought in local tech startup company owners and other CEOs and brought them in to tell them what happens when you start hiring, what makes somebody more marketable versus another one. Furthermore, we start going from the ground up. Not only how do you write hello world, but what are classes? What are meta classes? How do you do generator functions? And how do we do this as convention in accordance with all the PEPs? And that's where we've started, and it's almost like a co-learner environment, but I've been leading this. And the reason I come to the lightning talk here is not only is it education, it's education at higher education level, but I need help because I am not a programmer by trade. And so I wanted a chance to sit here and network with people that are in that trade, that are professionals, are in the industry, and are the leaders to tell me maybe here's some resources, or here's my CTO's number, or something like that, so that I can actually do that networking and bring that back to the University of Michigan so that we can continue creating people that can easily matriculate into industry from academia. In any case, thank you.
Dan's going to be Eric. Nicholas. Who's going to be after that? All right.
Okay. Hey everyone, I'm Al. I just came up with the idea for this lightning talk, which will probably be about 2 minutes actually. And it's not even presenting information. I just have this question that I would like to take this opportunity to ask everyone here at the Education Summit. Right, so who's heard of Logo with the turtles and everything? Like nearly everybody, because it's been around for 50 years almost, I think. Yeah, like 1960s was when Seymour Papert and others created it. And it's a really useful way to introduce programming, because programming is just, you know, abstract, and much as some people love calculating Fibonacci numbers, it's not really a thing that kids love so much. So, you know, Turtle gives you this turtle object. Seymour Papert, he wrote this book, Mindstorms, where he calls it body syntonic reasoning, where you can tell, like, oh, I have a body, I know what it is to move forward and turn to the left and do that sort of thing. yeah, Turtle is a really great idea, and lots of things have copied it. So this is Carol the robot, where you have this 2D world, and then you have an object in this world, and then you move it around. And I started seeing this over and over and over again. I mean, Scratch has its own turtle drawing stuff. I'm actually going through a bunch of slides, so you might want to like jot down some of these. And we've kind of been copying this theme over and over. I call it the 2D grid world way to introduce programming to people. Turtle.py, Python has its own turtle graphics thing. Processing is kind of different. I mean, I guess Turtle isn't so much a 2D grid world because it's not discrete units that you're moving around, but continuous, and then processing is sort of the same thing. You have like animation. Now, there's this old Flash game called Lightbot that is now a popular app. Again, this is isometric, but it's still just a 2D grid world. You program this robot to move around and solve these little puzzles, and you use loops and if statements and functions and that sort of thing. Minecraft, oh yes, so this is a 2D grid world except with an extra D, I guess. It's just 3D. There's a mod called Computercraft that adds these programmable robots. So now you have robots moving through a 3D world. Same thing, it's the 2D grid world over and over again. They even have an Hour of Code Minecraft themed thing that is more 2D grid world programming. And, oh yeah, Conway's Game of Life. Nikki Case has this like emoji simulation world that's sort of similar to Conway's Game of Life. Again, another 2D grid world. And yeah, so I started wondering, you know, is this sort of like what we're, like 20 years from now, is this how kids are still going to be learning how to program? Are we going to keep using this paradigm over and over again? It's kind of like, I feel like that can't possibly be it, but I have trouble imagining what's going to be the next step. It's sort of like when I tell people like, young kids like, oh yeah, Netflix, instead of downloading movies, we used to have them put on shiny discs and then mailed to us, and that would take days, and then we would put it in. That seems so ridiculous, like that can't possibly be what we're gonna do in the future. And I think the same thing about 2D grid worlds as a way of teaching programming, but I can't really think of anything better. So I wrote this one book, Hacking Secret Ciphers in Python, and this is a book for programming. This is something that's not a 2D grid world because you're doing like little Caesar cipher encryption things, and so you're just sort of manipulating data. Another example is Twine and interactive fiction. This is kind of just, you're creating your own choose your own adventure style book. Another thing is sort of SVG, where it's not quite programming, you don't really have flow control and variables, but it's something more than just a 2D grid world. You're actually defining shapes and that sort of thing. But it's something that I would just like to pose as a question. Are we gonna keep doing 2D grid worlds as our tutorials and just kind of extending out Logo forever and ever, or what's gonna be the next major thing that we're gonna realize like, oh, this is a great way, young people and beginner programmers really love it, and I have no idea what that is, but if you have an idea or you wanna talk about it, then just find me around the conference. Thanks a lot.
Oh, excellent. Hi, I'm Dan Posemanter. Who here has heard of Philosophy for Children? Yes, awesome. Oh, of course. Yeah, that makes sense. Excellent. So basically, Philosophy for Children is essentially the same sort of concepts and ideas that you might tackle in the college course, presented as early as first grade or kindergarten. And it works exceptionally well. But there is usually that first pause, especially if I go to a school and they say, oh, I'd like to do a philosophy program with your second and third graders. They go, this is an elementary school, not a college. But the way it works is you simply use language at whatever level you're teaching at. So for example, anyone can understand the question, well, how are you sure that you're awake right now? How do you know you're not dreaming? Or, for example, the question, is it ever okay to trick someone into doing the right thing? So who here knows the story Stone Soup? Yeah. So that's essentially a story about tricking people into doing the right thing. Oh, we're hungry. Well, we're not going to give you food. Okay, well, we don't need food. We just, we're just going to sit here and make some stone soup. But it would be better if we had some onions. And then eventually it starts building and building. Oh, the soup's really great, but it would be better if it had, maybe some chicken and some spices. And eventually these travelers end up basically tricking an entire village into giving them food, and it becomes this whole big party. Digression. So, why does philosophy for children matter to teachers and programmers? At its core, philosophy is reasoning skills and communication skills, or I should say are. It's another way to work at the core cognitive skills behind what drives programming, what drives math, what drives language arts. If you have a group of kids and you're talking about, well, how do you know if you're dreaming or not? It's an opportunity to invite children to think creatively and to arrive at conclusions on their own. And that part should sound very exciting to anyone who teaches programming. Because what makes programming so cool, what makes it so engaging, is that programming ultimately is about self-directed learning. And the coolest thing from my perspective as an educator, and the most interesting thing, is this idea of how do you make ideas stick? How do you get kids curious and interested and get them to come alive? And the way you do that is you let them arrive at the conclusions on their own. A conclusion a teacher imparts to a student stays for a while. A conclusion a student arrives at on their own, they own it. It's theirs. They found it. So the purpose of this lightning talk isn't to go over the whole of philosophy for children or that sort of thing, but to introduce the idea that working philosophy into the curriculum can build on the same cognitive skills that you'd find in a programming class or that you'd find in any other core class at a school. And underneath that is another exciting possibility. This isn't the case everywhere, but certainly in the US, there's this huge pressure to teach to the test. And anyone working in a public school in the US who's working with kids in a programming class, probably they're worried about the kids passing whatever math or language arts assessment is in a given state. If we approach education from a holistic standpoint and we look at different ways of getting to the same end goal, then suddenly kids who are struggling with math, well, now you have two different ways in. You have philosophy and you have programming. And in both cases, you're working on that ability to reason in a way that's self-directed and fun. And that's it. Thanks very much.
Thank you, Dan. So Eric is going to borrow my machine, so let me get set up. After that, Nicholas Matthew W. will be walking us through keeping students in the flow state. Let's see. Looks like you're good to go. Thank you. Thank you.
All right. Good morning, everybody. It's nice to be here. I'm on a 2-year PyCon schedule. It's nice to be back. So I teach a little bit about myself for perspective on this. My father was a programmer in the 70s, so I got to write my first program in BASIC on a kit computer in the basement in the 70s. I got a BS in physics. Wasn't sure what I was going to do, and I went into teaching. I was going to be a particle physicist, but I wanted to not be a student for a little bit, so I became a teacher. And I love teaching, so I stay with that. I consider myself a lifelong hobbyist programmer. I've taught 6th through 12th grade math and science in New York City and Alaska. I live in Alaska now, probably will the rest of my life. I wrote Python crash course through No Starch Press. My lifelong goal, though, I keep coming back to, I want to use programming to make education better for everyone. So this is where I live, Sitka, Alaska. We have 9,000 people about. There's about 400 high school students. We're an isolated community, big enough to be fun, small enough to be isolated. So let's look at our graduation requirements. If you're going to graduate from our school district, you need 23 credits. You need 4 credits of English language arts, 3 credits of math, 3 credits of science. One of those has to be life science, one has to be physical science, and there's more. So I'm showing you this because if you're a student or a parent or supporting somebody who wants to graduate, this is a lot to take in. And I know it well because I've had this conversation hundreds of times. So this is our official transcript. When students want to know if they're on track to graduate or parents want to know if they are on track to graduate, this one's hard to read because it's small. But if we look at social studies, the core questions that people ask, again, students and parents, is what requirements have I already met and what classes do I need to take? And even from this, I would take down a piece of paper or write on this transcript for the person, oh, I see that you have 0.75 credits of government, you need a quarter credit of government, you have 0.75 of, actually I'm getting that wrong. All right, you can see how that process goes. So how does Python help? I have access to our student information system, so I know that we can generate text-based transcripts, which look even worse for parents, but I can take that and do anything I want with that. So this past year I made visual transcripts for all of our students, and this is the first page. So looking at social studies again, asking those same 2 questions, what requirements have been met, what classes does this student need to take, we can see, all right, they're partway through social studies. They don't need to take Alaska Studies. This is helpful because if a student is offered a really interesting version of Alaska Studies, they might want to take it. They can take the class, it'll help them towards their 23 credits, but they do need to know that it's not a requirement for them at this point. So this is the boring conversation that we have to have with every student. How much credit do you need to graduate? In which categories? We used to figure this out while sitting down with every student individually. And now this is spit out for us. We can focus on the interesting conversations like, how are you doing? What are you thinking of doing after high school? So connecting the class that they need to take with what they actually want to do. So what's next with this project? I did this basically in one day of in-service at the beginning of the school year. I had a day where I could do anything I want to get ready for the school year. And I thought if I could get this done, I'd save hundreds of hours of our staff time over the course of the year. And it worked. It's ugly code, but it works. So there's some improvements I could make. It'd be nice if it was on one page for everybody. It's in use at my school. I teach at a small alternative school. Next year, it would probably be useful for the rest of the schools in my district. Beyond that, I'd love to share this wider, but the proprietary issues of student information systems are mind-boggling. And then you get into inconsistently stated requirements across states, and it's a fun, big, messy problem. So, I do love talking about this, so if you have any thoughts about this or education and programming, I'd be happy to talk to people. Thank you.
Thank you, Eric. After Matthew, it'll be Scott talking about CircuitPython, Python on hardware.
Okay, hi. So my name is Nicholas, and as you can probably tell by my accent, I'm from the UK. And I'm here, well, let me ask you a question. Could you put your hands up if you're having fun today and enjoying yourself? I think that's pretty much everybody. Wouldn't it be cool if we did this again, but we didn't have to wait a whole year till the next PyCon? Wouldn't it? Yeah, it would. How many of you have ever visited the United Kingdom? That's not enough of you, you see, because the purpose of my lightning talk is an invite to the UK. Let me just, there we go. refocus things. So PyCon UK is a PyCon just like this PyCon. It's a little bit sillier than this PyCon because we tend to play more on the Monty Python link, and being British, there's lots of jokes and so on and so forth. And since 2011, we've had an education track. I'll tell you a little bit about what happens in this education track. So we have 2 days in our education track, and it would be wonderful if we could see some of our American friends there as well. On the first day, we have teachers, and this is a group of teachers and a group of developers. And teachers come along. We have a significant minority of our attendees are teachers at PyCon UK. They sort of turn up looking like stunned rabbits because this is a rather intimidating situation for them. They are at a developers conference, and they soon realize, and it's usually about, I don't know, coffee during the morning breakfast, that they realize that actually this is going to be a lot of fun, and it's not like teaching conferences. I used to be a teacher. I've been to teaching conferences, and really I'd rather stick forks in my eyes than have to go to a teaching conference again. Anyway, so they enjoy themselves, and they get to know developers, and they realize that developers aren't these intimidating sorts of people that they might think of Neo in the Matrix. I mean, we don't do kung fu and that sort of stuff. We're actually friendly people, and we want to help people out. And this is last year. So we have about 100 people in this room, and these are developers and teachers working together to create resources and learn from each other. Because, as we've learned this morning, teaching is also an important skill as a developer. And developers having to teach to teachers. Teachers are going, well, perhaps you could explain that a little bit better by doing blah, 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 blah. And we also have the Kids' Day as well, which is the next day. We encourage the teachers to come back because they then act as teaching assistants for those of us who are leading the Kids' Day. This is my favorite sequence of photographs from any possible PyCon ever in the universe. And this was a few years ago. The little boy is William. He's my, well, he was about 5 at the time. He's my son. And next to him is Amelia, who's about 7. And the kid, it's like having kind of, I don't know, monkey infestation at the conference. So the kid with the mouth in the corner, that's my other son. And they're playing with Minecraft, with Python, the Python API, and they're trying to make it work. And something's gone wrong, and they're trying to figure it out. And so William's taking the keyboard, he's pressing things, and is it going to work? Is it going to work? I don't know. No, it doesn't work. But Sam, big brother, he knows what's going on, so he's going to point something out. It's that thing. It's a syntax error, you see. You've got to put a colon there. I don't know. This is Python. And they run the code. Is it going to work? Is it going to work? Oh, the tension's building. The tension's building. Yes, obviously, this has worked. And we get lots of moments like this at PyCon UK in the education track where we give the kids quite a lot of autonomy to explore. It's not a formal learning situation. It's, like I say, a kind of like monkey infestation, really. Well, so you're probably asking yourself, well, where is PyCon UK? I'm assuming you all know where the UK is, and UK means United Kingdom, and so we are 4 kingdoms. So you're not coming to England, which is where I'm from. You're going to Wales. I've helpfully marked it on the map for you. It's the sticky-outy bit on the left-hand side. Scotland's the sticky-uppy bit on the top, and Ireland is a very complicated place for historical reasons. And it's in Cardiff, which is the capital city of Wales, which is a very beautiful place. How many people here are Doctor Who fans? Oh, come on. It's where they film Doctor Who. There's the Doctor Who experience. You can go and cuddle a Dalek or something like that if you want. And there's lots and lots of culture in Cardiff as well. And we actually hold it in the City Hall, the Victorian Hall. And this is just one of the rooms that we use. And it's kind of like a film set, really. It's a magnificent building. There's lots going on in Cardiff. And if you think, well, great, I must go and come along to the education track at PyCon UK, then 2017.pyconuk.org is where you can find the newsletter. You'll be able to sign up then. Okay, that's it from me. Thank you.
Flint. Excellent, Flint. Thank you. Talking about visual bash. Awesome. Let's see if this works.
That'd be super great if it did.
Does the magic happen?
Can you go to your display settings? Let's make sure.
Displays.
If you guys like the lightning talks and you've never been to PyCon,
Yeah, so, I mean, this is what I've typically had to do in the past.
lightning
Plug
talks
it for me
run
one more time.
during
Display
the course of PyCon. I think there's
Oh,
like
you can
one in
leave
the
it
morning, one in the
connected to the
afternoon.
I'm just making sure this
probably
isn't all
Friday
right.
and
Gotcha.
Saturday. Those are actually probably my favorite part of PyCon outside of this space.
Hey,
All right.
cool. Got some awkward height things going on here. It's helpful if I see these two. All right, can you guys hear me? Cool. Slide. I like Vim, so I just wrote it all in text. Do you guys want white on black or black on white? Anybody? Black on white, white on black? White on black? Stay in Vim, great. All right. So, I love lightning talks because you can talk about anything you want. So my name is Matthew Weitzel. You can find me on Twitter. I tweet about ducks. This talk is ducks, the walking, flying kayaks you can be friends with. That's not true. I'm actually talking about how we can keep students in the flow state, but I have your attention now. So there was one slide in Charlotte's talk that was talking about distress versus eustress. And a different way to talk about this is a flow state. The idea is if you are doing something too trivial or mundane, you kind of mentally check out. But if you're doing something so hard that you can't make any progress, then it's just grueling, taxing mentally, and there's no reward. But there's this sweet spot in the middle that's it can be called the flow state, and you want to keep your students there. So who am I and why am I talking about this? I used to be a teacher at Dev Bootcamp and quickly switched back to development because I got to keep my hands in the code. That said, I love working with junior developers, mid-level developers, senior developers, anybody I can learn from or offer a lending hand to. I love that I've had a close encounter with people who are deeply passionate about pedagogy. So one thing that I found really unique is that students don't know where they should fail, and often we think we do, but we're wrong. And there's a couple really cool examples I wanted to show you about this. So as educators, it's our responsibility to not tell students that they should fail. Like, we want them to succeed. So a really good way to do that is to set them up to hit the ball. There's this beautiful talk by Alan Kay on tennis. It was two great quotes. The beginner tennis involves a lot of chasing the ball, and no other form of tennis involves chasing the ball. All of them involve hitting it, and that's what we want people to do. So we want people to be right there. I highly recommend everybody watch this talk if you're an educator or an educatee. It's brilliant. We want to learn how to do things like recognize what it means to be chasing the ball and what it means to be hitting the ball in your field. Another example is slacklining. It's a sport where you take a piece of rope and you stretch it really tightly and you try to stand on it. The beginning slacklining involves a lot of landing on your face, and all other forms of slacklining involve not doing that. One example is my cousin had come to slackline with myself and some friends who have been doing it for years. He didn't know that he was supposed to fall, and he was surrounded by people that were just doing it really well. And usually there's like an 8-hour of falling on your face fest, not an exaggeration. And he just got right up and started walking because he didn't know he was supposed to fall on his face. You just don't tell people where they're supposed to fail, and it turns out they won't. It comes down to a couple different pieces. You need to provide students with safe places. We need to recognize what it looks like to chase the ball and what it looks like to hit the ball. You need to celebrate in failures because those are the first steps into learning, and we need to show them success. So one example I wanted to show you guys was what this looks like to hit the ball. Who has ever seen a stack trace and been terrified? I have. So this is from a project of mine. It's a game called Tachyon Run. I, due to work requirements, could not pick up. It's a side project of mine, and I couldn't pick it up for months. And I just ran it. So I was like, cool, start the server. Stack trace. So one of the things I like to teach students is how to read a stack trace. So one of my favorite tricks, just as an example, I like to search for the project name. And then suddenly this wall of text becomes this really illuminating thing. So simple things like how to read a stack trace, we want to give our students these tools to set them up for success. So it becomes really clear that I just didn't say which port I was supposed to run the server on. That's great. Students don't know that kind of thing. So thanks for listening. Thanks for listening how to keep students in the flow state, and I appreciate your attention.
Thank you, Matthew. While we're getting set up, just a heads up for what's going to be later in the afternoon. We're going to have 2 unconference sessions. Over there in the far side of the room, I've got some papers set up and I've got some markers laid out.
Yeah, that'll work. Thank you.
What we'd like to do is gather from you some ideas of things that you would like to talk about for essentially the last 2 sessions of our day. Everyone will be given some Post-it notes, and you can wander around and you can look at the ideas that each of you has suggested, and you can kind of vote for the ideas that you want the most. And based on the number of votes, we will schedule kind of those 2 conversations. Just a caveat as to what the unconference style conversation is going to be about. This is not a chance for you to say, I want to talk about my pet project and tell you about how awesome I am. This is, I want to have a conversation about a topic. I'd like to get 8, 10, 15, 20 people in the room, and we're going to talk about this topic. And there's essentially a speaker for that. It's we will communicate together, right? So whoever comes up with the idea might facilitate the conversation, but it's not a chance for you to present. It's a chance for you to put up the idea of what we're going to talk about. So over the lunch break, make sure you go fill out some ideas. We'll get everybody to we'll give you some Post-it notes, and you'll vote for the ones you want by putting your Post-it note on the things that are most interesting to you. And I'll turn it over to Scott. And
hi, thank you. Hi, everybody. My name is Scott. I'm a software engineer by training. I kind of do teaching when people need to be taught, I guess. I did TAing when I was in university, and now I work for this awesome company called Adafruit. They're a company that started over a decade ago by this woman, Lamore Freed. She goes by Lady Ada. And she basically started the company because she was teaching people to build electronics, build things out of electronics. And they wanted all the parts together in one place. So she did that, and the company's just grown and grown with the idea of teaching people how to build things for themselves and selling them the things that they need to build it with. So I'm relatively new to the company. Out of school, I went to Google, and I was there for like 6 years, and then I was like, I'm done with this. So now I got lucky enough, and now I work with Adafruit directly with Lamore. She does a ton of engineering still. Tony's over there in the pink. He also works with Adafruit. He's got a talk later. You should go to it. But in this lightning talk, I just want to talk about Python and hardware, which is still relatively new. So this board here is called the Circuit Playground Express. It was launched yesterday, actually. It's actually on sale today sometime, so sign up. And I have some prototypes here. They're purple because they're prototypes. And I actually want to do a live demo. So the idea is to get Python running on this. And we're building off, I just want to give some credit where credit is due. There's this project called MicroPython. You've probably heard of it. It's a couple years old. It was created by this guy, Damien George. He did an awesome job getting essentially Python 3.4 running on a microcontroller. A microcontroller is a very small, inexpensive computer, all in one. They're like, so these boards are $25. That's how inexpensive they are. And all of those of you who like the old 1980s era computers, well, this runs at 48 megahertz. So eat your heart out. 32K RAM. Anyway, so I want to do a demo. One of the things with working with hardware is there's usually a lot of tools that you have to do to get set up. But here, and I don't know which demo is which, you just plug it in. So there's some code on here that's running, and I can actually touch some of the pads and the red lights will go. So there's some Python code underneath that. So how do I find the Python code? Well, if I can manage to look on my tiny screen, because I'm projecting, And this new drive has showed up, and it says CircuitPy. So we've taken MicroPython, what they've built, and we built on top of that what we call CircuitPython. This is called the Circuit Playground, so we have CircuitPython to go with it. And that's what I've been doing for Adafruit. So now all we have to do is we have to double click, and now we can see a couple things. We can see a boot.py, and we can see a code.py. Well, let's take a look at that. Thank you. And Atom will open. So I just double clicked it, and now I'm seeing the welcome screen. But this is the code that's running on here. So I won't go through it all because this is a complicated demo. But this was intended to test everything that's on here. So I'm actually going to close this, and I want to do the other one. So these two boards are identical, but they do different things because of the software that's on them. So this board actually has both a microphone and a speaker, along with a bunch of other sensors and stuff. And so I just want to do the same thing I just did, and it's going to hiccup a little bit as I open the files because my code is, needs a bigger buffer. But here we can see there's a WAV file here, and there's a code.py. So if we just open that, we can now look and see what's going on. I actually have some control here for when a button's pressed. If I want to turn it off, there's a slide switch, and now it's off. There's a button I can press, and I'll keep playing. And it's pretty simple. It just says, load this file, just standard file open, and then play it. And while it's playing, we can say speaker enable equals the value of the slide switch, or if the button is pressed. And that's how it's going, and we've done this, what I think is a cool demo, in like 24 lines of code, which is actually more than we need. We could do it with fewer as well. So if you're interested in getting kids coding with physical things, Tony's got a great talk coming up later, and we're going to be around all day and all conference. We're going to have an open space. We both brought tons of boards from Adafruit, all different sizes and shapes. Some run Python, some don't. So if you want to check that out, come find us. Thank you.
All right, so Alan's going to get set up. Coming after Alan. Going to break for lunch. Following that. For the unconference, we'll have a stack of Post-it notes. Take 3 Post-it notes. That gives you essentially 3 votes. You can distribute your votes however you want. If you want to put all 3 of your votes on a particular topic, if you really hope that topic gets picked, you can do that. If you want to hedge your bets and spread your 3 votes out to multiple topics, in hopes that one of the 3 or 4 topics you like gets picked, you can do that as well.
All right, yes. All right, I'm the last thing standing between you and lunch. Oh, sorry, there is one more. All right, very good. All right, so this better be good. I want to share an idea with you about what programming is like now that Python is in the world. In the first generation of programming languages, programming was an act of translation. We would express ideas in mathematical notation and then just translate them, which is why coding is called coding, and it's why Fortran is formula translation. But this has changed. And an example I want to give to show how it has changed is breadth-first search, which is one of these fundamental computer science algorithms. This is how you would explain breadth-first search in 1989 in an algorithms book, which is this mishmash of kind of like a programming language and kind of like mathematics. And then gradually we got pseudocodes that would look more and more like this. So this is actually on the Wikipedia page for breadth-first search right now. This is the pseudocode for breadth-first search, and this is the Python for breadth-first search. And the thing that I think is notable about this is that the Python is a more readable way to express this algorithm. It's more concise, it's more expressive, and incidentally, it's also executable code. unlike pseudocode. So this really changes the nature of what programming is, because it used to be that we would have to do our thinking in natural languages and then translate that into mathematics and then translate that into code. And every time you do a translation, you lose something. You're restricted to the subset of ideas that we can express effectively in all three of these languages. So this is my attempt to explain what I think has changed here. What natural language has going for it is expressiveness and readability or comprehensibility. Obviously, we naturally understand it. Mathematics notation has the nice property of being very concise and being much more precise than natural languages. And then programming languages have the killer feature of being executable, which makes them testable and shareable and distributable and all that. Python, I claim, has all of these properties and in some sense makes the other languages unnecessary. So instead of that three-step process, you can potentially do your thinking in natural language and then go straight to Python without trying to express it mathematically first, or even just skip the natural language part and start thinking in Python. So I think a bunch of things happen if you can do that. When you take ideas out of your brain and express them in the form of code, they become shareable with other people who can see it. They become inspectable. And when you debug the code, you are debugging your brain at the same time. You are debugging your understanding. Incidentally, the code that you write might be useful because it's executable code, but you've got all these other benefits that happen too. So this is my claim that modern programming languages, and to be fair, not just Python, but others too, are a qualitatively different tool from what early programming languages were. They give you tools for communicating and for thinking, and particularly relevant to this group, for teaching and learning. And I didn't talk about the teaching and learning part in this quick talk, but I have a longer version of this. This is an article from a couple of weeks ago. The Scientific American guest blog picked up an article that I wrote about these ideas. So there's a little bit more there if you want to check it out. The link is there, but actually if you just search for my name, Downey, D-O-W-N-E-Y, and Scientific American, you will find it. I'm going to leave that up there while the next person comes up. Thank you all very much. I'm just waiting for you to get here before I unplug. All right, it's all yours.
All right. So Flint really is the only thing keeping you guys away from getting lunch.
Yeah, got that. Following Alan Downey is kind of like offering guitar lessons after Jimi Hendrix has played. I'm Paul Flint. I run the Barrie Open Systems Institute in Barrie, Vermont. We may get video, we may not. You never know. I'm here to talk to you about something called Visual Bash. And basically, Visual Bash is actually beyond just being a way to bait the Microsoft legal department. It's a legitimate idea, and who knows, I might even be able to get it up on the screen here, one never knows. Oh, look at that. Wow, miracle about miracles. Okay, but I'm not really here as a speaker. I'm more here as a, let's see, is this going to actually work? Oh, good, now we're in that mode of operation. I'm ready to shut this down. I'm really here as a heretic and a thief. The deal is that you won't see anything, guys. Sorry, it's not going to work. Apparently not. Or maybe yes, it will. Okay, so let me see if I can make it work. Okay, page down. Okay, so we'll try for that. So Visual Bash started when I started using the bash command line, and I discovered that the command line was where we all began, and why I couldn't continue to use the command line was kind of beyond me. And so and you tended to make commands just you start on the command line, you just start adding stuff. You know, you start, this whole pipeline thing got you. And you're making these pipes, and you're piping and piping and piping. And the next thing you know, you're down like 3 lines down, on the command line. And this is just the way you do things. And so next you find yourself, you find yourself echoing the command line out to a file and expanding this out from single lines to multiple lines. And you're writing a program, but it's not really, you didn't really sit down to write a program. You sat down to figure out something, okay? And you're at this horrible thing called the command line. But eventually you start making friends with the damn thing, okay? And you know you're in deep trouble, okay, when you're in the editor and you figured out how to get the line counter going, and it's line 500. Oh my gosh, what have I done? Now I have to deal with this. So I started to really think about this. And I came up, and this is the silliest idea. I came up with this idea of a framework or some structure that you can add to Bash, of all things. Because you can do anything in Bash. I mean it. And that's the heresy, okay? Because this is a Python conference. Who the hell invited the Bash boy, okay? So that's how it all got started, And so what I developed was this overall framework, okay? And it's Visual Bash is all about 3 elements. Functions, lots of functions. Lots and lots and lots of functions. An evaluator, which is the ballistic line of code you hit when you enter the program, okay? And then something called a dispatcher. The evaluator does only one thing. It counts the number of variables, figuring out how many variables there are you've handed to the program, okay? It can be 0, it can be infinity. It doesn't care. The dispatcher is just basically a big case statement that takes a number evaluated from the evaluator and applies it to a case statement, okay? So this is what, if you got 8 variables, this is what it's going to do. If you got 1,000,000 variables and the first variable is pipe, this is what it's going to do, okay? And there's something called the shebang. Now, raise hands. Who here knows what a shebang is? My gosh. Okay, so, yeah, and you have to, because in Python, if you don't, you're in deep trouble. So we expand the shebangs. We use pound to symbolize help, all kinds of different shebangs. I have a bigger and expanded version of this talk that I'll be giving at some conferences around the country. It's cross-platform. That's the wonderful thing about Bash. Just like Python, it runs on, of all things, IBM mainframes, Windows, Macintosh, Linux, Unix. As a heretic and a thief, note that while I love Python, I'm here to espouse the born-again shell. I'm here to steal as much Python as I can and stick it into Visual Bash, particularly doc strings. God, is there something to love there? Okay, that's all I got. Any questions? Thank you very much for listening. Wow, that was a rocky start. Jeez. Let's go eat lunch.